but he's got to back up. Mian and Dust, unfortunately, it's not enough. And now they've got to think twice about how they want to position here as Old 11 is looking to be the +1 and Poyoyo jumping through the trees. Tarzan at that. Can they cancel the TP? They can. A Burrow strike is there from Old 11. And will be 2 kills picked up here in the bottom lane. Even DY
nice glimpse.
coming in for some assistance.
That's a free kill.
Well.
Yo, welcome to the stream. What's up, guys? Actually, I should go. Let's look at Hacker News. Or we can just watch Dota. I don't know. We're just chilling right now until the coaching starts. So if you guys have like questions and shit, feel free to ask them while you still can. You know, we're gonna have a pretty long stream today. It's gonna be 4 hours. No, it's going to be a lot of stuff to cover. So hopefully you guys stick around for all of it. So the first half we'll do coaching. The second half we're going to talk to one of my clients who got a staff engineering job at Wayfair. And we're going to talk about his coaching experience, what it takes to get a staff engineering job, and really like the overall process of getting it. So yeah, hopefully you guys stick around, and yeah, let me know if you have any questions. So for people who don't know, hi, my name's Edward. I am a coding interview coach. Used to be a senior engineer at Apple. Now I currently am a senior engineer at Uber. And so in my off time, what I do is coach engineers to getting whatever offer that they want, really. Within reason, of course. But this has been like my primary focus for the past few months, on my off time. So this stream here is more or less just an educational one. Hopefully you guys watch the coaching sessions that I do with my clients, and you learn a little something. Hopefully it's about your upcoming interview, maybe something you learn a little something for it, or maybe it's just about your career in general and how you should think as an engineer. So, welcome, and yeah, feel free to ask me anything you want. We got like 8 minutes until everything kicks off, so in the meantime, we're going to be watching some good Dota. Chinese Dota at the moment. Ooh, is this Ori who's playing? Yeah, Ori's on Vici. Yeah, this Quap is dominating. I don't think Quap should be dominating the TA matchup that hard, actually. I feel like it goes 60-40 Quap. And the fact that this TA died twice is really, really bad, actually. I feel like, yeah, you might have Lance at this time, but the Quap is literally just shutting down your safe lane. Your Razor has no farm. So it's all on the TA now. They're just gonna... Yep, there we go. They have no way to defend this mid tower unless they bring the Timber Saw. Oh, they could just glimpse the Timber back, actually, but I guess they really want to fight him. Yep. Ooh. Wow, he's actually alive. Jesus. Nope. Okay, that Timber died. That's really bad. They lost this fight. Yeah. Yo, what up? Hi, Harash. Don't worry. It's 7 minutes. In 7 minutes, you'll know now. But don't worry, we're gonna have fun here, hopefully. But I'm gonna be a total hard ass about all this. We're trying to get you the offer, man. We're trying to get you the offer. Yeah. That's like that Timber Saw died so fucking fast. Actually, that's like. Oh wait, yeah. The Timber Saw should not die that quickly. I feel like they're just like completely different. Hold on, I'm gonna get some water.
Another pickoff actually on Kaz. PYW is the one to find it, and again back into this triple null. That spell ant feels really nice to help kind of shove out these lanes, and this is also pre-Orchid with all the kills they've been finding, and quite honestly, like when you've got a bounty hunter on your team, I mean they just picked up level 6 or TZY.
Oh, they got the Timber Saw again. Yeah, I think he dies here. Yep. I mean, I don't blame the Timber Saw for feeding. He's the only one who can defend against the mid tower push, and he's obligated to do so. TA's not online, Razor has nothing. He's the only one who can do it. So, yeah, I think you wait for BKB timings. Yeah, you need BKB timing on the Razor, but he's just way too far behind.
is what enables it for Magma. But currently Vici are the
Does the
ones
TA
coming out
can
on top
TA
of
come
that.
back into this? I feel like the map's just being shut down. Like all the farm will just go to TA. There's going to be nothing for the Razor. There's literally going to be nothing for the Razor. He's not going to be a hero this game. Ooh, big, and the Monkey King knows this. He's just going for big crit damage. He doesn't give a fuck. Oh, he's okay. The Razor recognizes it, and he recognizes he's rushing the BKB. Yeah.
So he's got to max out.
Yeah, I think they're gonna aim for like the 20-minute timing, but I'm pretty sure that Vici Gaming I can just kill them once or twice and take Roshan, and then after that they don't. There's nothing that they can do.
It's definitely not the greatest farming
Let's see what
utensil,
Quap has.
like some other heroes,
I'm
but
pretty sure Quap just gets.
you gotta make do with
Does
what
she
you
get an
got.
Orchid
It's
here?
okay.
Yeah. Or does she go like big damage and just go rush the eggs?
Chakra as well, but
Holy shit! Quadruple null for the Coddle. Okay. I'm not gonna lie. I've seen fucking like carry Coddle or mid Coddles, and all they do is like go double null and Dagon, and it just allows them to clear the wave like so quickly with the double null and boom. Yeah, that TA is nothing. Boom. Yeah, that Timbersaw is sad boy right now. There's literally nothing they can do right now. I think if you're Quap, you just go for the Ags. Go for the 40-second cooldown on the Scream. Like, the Orchid doesn't really help you that much, I don't think. I mean, at best, you're just going to be jumping the Lion, but then it's like, you blink in for the Lion, and then what? Alright. You know, let's look at some hacker news today. Let's see what's going on. I know GME did some GME shit. You know, GameStop. Like, I don't know if anyone's been following this, but like, this fucking parabolic shit. Like, Jesus Christ. Like, okay, it's just GME does this once every 3 months, and it's just some weird combination of like volume traded, low liquidity, and then just like Twitter hyping it up. That's it. You get those 3 combinations, then you're just gonna have this parabolic spike again. And like for the past year, you've just gotten it basically once every 3 months, like March, and then June, and then you're gonna get that spike again. Although I think you just cap out at like 250, right? And then you're just like bag holding this entire fucking time. And then like every single hedge fund in existence is just walking down the price. Because at this point, it's not like retail that owns GME. Actually, it's just 2 hedge funds that are fucking each other. But that's a whole different topic to talk about. Hey Siddharth, what's up? Anyway, let's actually look at hacker news. See what's going on in the world today before we get started with coaching. So let's see, hacker news. Okay, Airbnb offers 20k Afghan refugees. Sure. Limits thoughts about antitrust. Open source not interested. This might be interested. Clinical trials. Design of a designer who Steve Jobs gonna hire. Nah. Okay, this looks like some management shit. Maybe I want to read that SQL model. Okay, I might want to actually read. Is the wrong direction. Okay. This is interesting. SQL versus NoSQL is in the wrong direction. A misconception is that SQL are relational and SQL are non-relational. Okay, yeah, I mean that's true. You can make a relational database out of NoSQL fundamentally, but this is kind of interesting actually. Let's see what it's trying to say. At minimum, relational databases expose data in the form of relations. Sure. AWS explains this distinction subtly. A relational database is a collection of data items with predefined relationships between them. Sure. Yeah, that's fine. And SQL only makes a appearance further down, explaining the structured query language primarily for relational databases. Fine. But I don't see what exactly the false dichotomy is here. The creators of Mongo seem to be aware of this misleading conflation of terms why they didn't go with SQL. Okay, fine. Yeah, NoSQL isn't accurate. We're really talking about horizontally scalable post-relational stores, not about query language. Yeah, I mean, that makes sense. If you want to make things scale horizontally, you don't subscribe a relationship to most of the rows, or else you have to manage them with, like, B trees. So I think I understand with the quote-unquote NoSQL being a misnomer. It's not, like, not having a structured query language or no structured query language. It's more about the structure of the data itself. So this is kind of interesting. Fine, I can accept this premise. The reason why we went with the query language representing queries as JSON, okay. if we're storing the JSON in the database, why can't we represent the queries themselves as well? Okay. So basically, MongoDB is just storing all the shit as JSONs, and then in a sense, they're just going to have the query language via JSON as well. All right, fine. Instead of having like your select star from column, and in order to specify all these relations, why not just make a query that just specifies all these characteristics in a JSON? So I think that's kind of like why he did that. That's fine. Okay, so then why is the distinction pedantic? Okay, SQL is versatile. Sure, retrieve OS on the fly. Relational database. Okay, yeah, so you have multiple querying languages. Fine. But then instead of dividing databases by SQL versus NoSQL, you could try dividing them by relational versus non-relational. Yeah, this makes more sense because implicitly SQL is. I think most people make this implicit association with SQL and relational, and then NoSQL and non-relational, and that's pretty much how it pretty much works. Because like with NoSQL, you have like document databases and you have like key value maps, and all of them kind of get put under this NoSQL moniker, but it's all non-relational data anyway. So I understand what they're trying to say here. They're really trying to deobfuscate this association, and that kind of makes sense. We can build semi-relational, yeah, and ultimately choosing relational versus non-relational is just based on your schema and whether or not that is performant. So if anyone wants to actually read this on themselves, I think the whole thing they're trying to say here is really just teasing out the relationship. But I'll link it in the chat for people who want to read it. But it's 8:31. I think it's time for coaching now, so let's bring on our victim or client, shall we say? Let's see what's up. Okay, I'm gonna bring him into the chat. Let's see. Yo, hello.
What's up, man?
Hey, nothing much. How are you?
Good. As good as it can be. Let me mute your YouTube.
All right, yeah. So say hello to the chat, and yeah. So let's give everybody a little background information about yourself. I know you've told me a little bit, but for the viewers out there, give everybody a brief rundown of who you are, like what you're aiming to do, and what you're hoping to get out of the coaching session.
Sure thing. My name is Brian. I am a software engineer, so mostly do front end work. And I recently got a recruiter from Google hit me up, wanting to schedule an interview. So kind of just been cramming until that first phone screen.
Yeah, you have a phone screen coming up. So quick question: how many years of experience you got?
Like a year and a half.
Okay, 1.5 years. So you're basically looking at pretty much a L3 interview, unless like you do Giga good and then get somehow randomly uploaded to L4, which it is like almost impossible with Google. I'm going to tell you straight up.
Yeah, that's what I'm expecting. L3 at best. And yeah, I forgot I didn't say what I'm trying to get out of the session. So really just looking for your expertise. I know there's big holes in my fundamentals still, but and I'm not expecting any silver bullet solution here, but your guide was great. So hearing from you directly is going to be fruitful, I imagine.
Okay, yeah, I'm glad to hear my coaching, my document helped you. So let me ask you this: where do you think you're really messing up? Because you mentioned before that you're kind of messing up on like some fundamental issue. Where do you feel like your biggest choke is for problem solving right now?
So with the problems and the patterns that I do recognize, I would say that my approach that I'm lacking is still like communicating my thought process. I think I'm getting a little bit better at that. Mostly talking to myself and my document and action figure. But outside of that, when I say fundamentals, I mean more so I was going to get into doing more like easy problems with graphs and trees and stuff. I'm moderately comfortable with arrays and strings right now, but yeah, that answers the question.
Okay, I see. So you're really talking about being more comfortable with a specific kind of topic rather than problem solving in general.
Right.
Got it. Okay, so then for this coaching session, you know how I will operate. I don't focus on trying to work on the knowledge basis. I focus on your pure fundamentals of problem solving and how you set yourself up for the approach, because this will get you the most mileage. You can always solve like a bunch of graph problems and tree problems on your own, but what I'm trying to do is like really get you to start thinking about things like a proper engineer. So
Okay, that's perfect.
great. So let me go ahead and share with you the Google Doc, and we will begin.
Sweet.
All right, cool. Let me resize the window and hide the URL so no one else like accesses the doc. We've had a few problems in the
Okay.
past with that. All right, let's.
All right.
Okay.
And let me know if my sound's weird. I have a fan in the background.
Okay. Okay, so then 824. Save. Let me share this with you. Link. Cool. And can you see that?
It's loading up right now.
Great.
Cool. Yeah, I can see it here. Let me turn off my other screen so I feel more in the zone. Okay. Second headset in. Let's do it.
Yeah, okay, let me bust out the timer. Cool. Alright, and then I'm going to pick a problem right now based on what you just told me. Let's focus on... And how many of my videos have you watched, or...
A good amount. A lot of your coaching videos, and I've watched all of your the videos on your playlist that was in regards to that doc.
Mm-hmm. I'm gonna tell you right now. I only asked that because I kind of want to know how much studying you've done. Most likely, even if you have seen this problem, I don't care.
Okay.
The reason
So you
why
still want
is because again we're focused on the fundamentals here. So like even if you do know the answer to it, I want to see your approach for it, and that's really what we're talking about today. So
Okay.
how comfortable are you with heaps, or do you not feel comfortable at all with them?
Not at all.
Okay, let's try something else then.
Yeah, I'm telling you, arrays and strings are like what I'm decent at. Not great. And then linked lists, I could do some easy ones. I think I can struggle my way through a linked list.
What about recursion?
I am up for the challenge. It's like hit or miss for recursion. So.
Okay, I see. Yeah. Let me look through the problem list.
Okay.
Let me go ahead because it's gonna take a little bit of time for me to find one.
No worries. Take your time.
Yeah.
That's more because of my ill preparedness than yours.
Mm-hmm. No, not this one. Okay. Oh, yeah, we can do this one. This one's gonna be pretty, this is gonna be pretty mechanical. I love giving these problems.
Okay.
So what I want you to do is to compute the spiral ordering of a 2D array. You might have seen this one before, but I honestly don't care. So what do I mean by this? So for instance, let's say I gave you a array like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16, right? I would want you to do this clockwise.
Okay.
So then what would it look like? It would look like 1, 2, 3, 4, 8, 12, 16, 15, 14, 13, 9, 5, and then 6, 7, then 11, and then 10. So this is like the output of it. So go right on ahead. Do you have any questions so far?
Yeah. So are we given whether it's clockwise or not, or is it by default clockwise?
You're given that's clockwise.
Okay. So it's always clockwise.
Yep.
Just to be clear. Okay. And then let's see. And so we're parsing through it in the order that the edges are clockwise. So let me walk through this. 1, 3, 4, 8, Okay, so it looks like we're at the very edges, and then 13 goes up to 5. Okay. So let's see, how do we want to approach this? And let me think if there's any edge cases. So can we assume that a single integer will equal we just return that one value, right?
I mean, technically, yeah, we can say they're integers for now, but in theory, I should be able to make these strings, and it should not have an effect.
Okay. All right, let me think about this for a couple seconds.
Oh, and for people in the chat, you should try this question yourself as well.
Yeah, we'll say I haven't seen this one, so that's good. So, is this like one long array, or is this an array of arrays?
This is a 2D array, so let me make this a little bit more clear. I'll just insert a table for your convenience. This is a 4x4, so then, yeah, so it'll look like this.
Okay. Can we assume that these are arrays of equal length?
For now, yeah, I think it's okay for you to assume that it's a square. Just for now. In theory, though, if I made it a rectangle, it shouldn't have an impact. You should be able to do it, but yeah.
Okay. Yeah, I'm not seeing any reasons why it wouldn't work with a rectangle, but just want to make that clear for now. Okay, so let's see. So we're an array of arrays. We want to get the edges clockwise. And I assume we always start at the first index of the first array?
Yep, start from the upper left-hand corner.
Okay. Okay, and then let me make sure I'm clear with everything before I move forward. And then the values themselves don't matter, right? We're just printing an array.
We're gonna be printing it out. Yeah. So you can just do a print. You can return a string builder, whatever you want. But at the end of the day, I kind of just want a string like this. So.
Okay, so it's a string. I was thinking it was an array. Okay.
No, I want you to print it.
Okay.
Out.
Okay. Cool. And like we said, we don't care about the values as long as it's in that order, the clockwise order.
Yeah, I mean, I could call this A, B, C, D, E, F, G, for all I care.
Yeah.
But this is just more for your convenience.
Okay, perfect. So then let's start approaching this problem. So what I want to look at is kind of a smaller example that I'll write out. So what would that look like? I'm just going to have the 1, 2, and then the 5 and 6. So 1, 2, 5, 6. So with this sub problem, if we want to return clockwise, what we're returning is going to be 1, 2, 5, 6. Okay. Well, I guess the combos aren't going to be there, but we'll worry about that later. So just first things that come to mind, obviously we need to iterate through the array. And what are we going to do with that iteration? So let's do this. Think of a brute force solution before we do anything. So clockwise would infer that we iterate through the entire first array, or the first subarray, and we might be building an array or a string. It doesn't really matter right now, but some kind of place to store the values that we get as we iterate.
Don't worry about storing it for now. For all I care, you could just do print. You could print it, whatever.
Oh, really? Okay.
Yeah, I
Okay.
don't care about that. The point is to be able to do the spiral computation.
Okay. So yeah. Okay. We're worrying about the actual spiral logic. Okay. So moving forward, so we iterate through the first subarray, turning that, and then what clockwise would be the end of this array, starting at 6. So in this example, as soon as we iterate through the first array, we want to start at the end of the next array. Um, I'm not really sure that scales for big problems yet, but let me think this through. So if we iterate forward on the first one and iterate backward on the second one, that would be clockwise for this solution. But let's say we had another problem here. We had another row. 8, 9. Would this work for this? So the first thing that came to mind was iterating through the even numbers, or sorry, let me think about how to explain this. So the first subarray is at index 0. So for that one, we would iterate forward, and then for every odd index of the main array, we would iterate backward. But I'm not sure yet if that works. So iterate first, do this first one. Not sure. Open up my something else. Okay, so iterate through the first one. 1 to 8 gets permanent, and then oh yeah, see, that's not gonna work. If we iterate backward, then it's not going through the entire 2D array. Okay. So
Okay, let me focus you a little bit, because right now I get the feeling you're just doing a magic bullet solution. Consider the simplest way of actually doing this problem instead of trying to come up with some random fancy hack. Try to come up with a simple solution first, and then building on top of it in a more efficient way.
okay, okay, let me think of that. So what does the grossest solution work? Or how would the grossest solution work? Okay, so so we still need to iterate through that first array, and then get all of the values of the end of all subarrays that follow, and then so we can keep an object or a hash map to see if we've, or actually even a set. So we can keep a set to see if we've arrived at that location before. That way we don't confuse things twice. Okay, yeah. So we iterate to that first array.
Okay.
Indexes of the last arrays.
Mm-hmm.
And then when we reach the last subarray, we iterate backward. And then we would also be iterating backward from this main parent array. And then, so we would be done with this array, the subarray. And then we're done with 5 already. So yeah, we would iterate backward to the 6, 5. That doesn't work.
Okay.
So we would need to iterate forward. So how could we do that? All right, I'm gonna go back to the example you gave me.
Yeah, just try to figure out how. Well, let's put it this way. This one is a simpler example to the one I gave you for sure. So let's make it very clear. What exactly is the answer that you're expecting from this?
We're expecting 128, 519, 856.
Okay, cool. Now, how do you actually get that answer? Like the algorithm that you ran through in your head. Just describe it in plain English for me.
That would be looking through that top layer,
Okay.
and then looking through the sides on the right,
Okay.
or the end of the square on the right,
Okay.
and then parsing to the left from the bottom, and then up one, and then to the right one.
Okay. Now, could you now that seems pretty normal, and you could generify it. Could you write that into a actual algorithm and make it a little bit more general purpose?
Yeah, I can.
Okay.
But can I do that with my brain right now? Yes, I can. So
yeah, just come up with a naive solution. Don't worry about getting some giga crazy clean solution right now. Get the simple one down. You can always optimize on it later.
Okay. Let's do that then. What does that look like? So iterate through top layer. As we iterate, we're going to print current value. And then that's going to be the case for everything that we do. Or sorry, every time we reach a value. So with this logic, the top layer is done. So I'm just going to signify that with these two dashes. Let me delete these. Okay, so now that the top layer is done, we need to get all the end points of the subarrays. So what we're really doing is iterating through parent array, and yeah, iterate through parent array, and all that is going on, or all the rest is going on between that. Iterate through parent array. Okay, that something started.
Necessarily parent is the right answer because this is like just the first array. There's no parent-child relationship.
Right. So can you? So I'm not too familiar with the verbiage for 2D arrays. So what would you call this array that's wrapping these subarrays?
Well, I just call it the first array, the second array, third array. You know.
Okay. Okay. Cool. So the first array encapsulates all the other arrays.
Well, the first array is just 1, 2, 3, 4, right?
Right.
So.
Okay. Okay. So, right. So let's go back to what I was thinking. So iterate to the top layer. And then on next array, we print, sorry, let's do this. On next array, print last value. And this is where I would want to keep in mind potentially if we've arrived at that point yet. So just gonna keep this in the back of my mind, track where we've been, but we'll worry about that later.
All right.
That might be an optimization.
Well, yeah, don't worry about that because I don't see how it works into your current algorithm. Do one thing a step at a time.
Okay, great. So on next array, print the last value, and then move forward, or sorry, move to next array, and then what do we want to do next? And then, so this right now I'm just applying it to this small sample set. So on last subarray, I'm just gonna call last array. Iterate backward.
Okay, last subarray,
And
iterate
then
backwards, sure.
print last value. So boom, boom, boom. And then once we've reached the end, we'll need to go one array up. And then iterate forward. I guess this would be the same step. Iterate forward. Printing current values.
Okay. So you're basically let's simplify what exactly you said, because this is very very specific, right? Essentially, what you're talking about is checking the top row, and then the far right column, and then the bottom row, and then the far left column.
Right.
Yeah, I feel like you could have just easily said that, right?
Okay. Right.
So so this right here is already telling me that you're just you're being way too pedantic. You're fussing over the details. But yeah, keep going. So now that I've laid that out for you, can you actually take what I've just that simplification and turn that into an actual algorithm?
Yes. Let's do that. I'm gonna keep this here just for reference. Let's go back up here. Sorry, I need to clean things up from my mind.
Yeah,
okay.
Fine.
So truck.
Don't do things in your head.
So,
write it out.
Okay. Would you rather I pseudocode right now, or
it's your here's the thing. This is your interview right now. I'm just litmus testing you. Do as you would do normally.
Yeah, normally I would do pseudocode first.
Okay.
That way I can step through it and catch the bugs before, and then we can worry about syntax later.
Sure.
Okay, so write a function. Just kidding. Okay. So what are we doing here? How are we going to iterate through this the way I want to? Sorry, let me think about this for 10 seconds.
Just take as much time as you need.
Okay. Okay, before I move forward, just for one last bit of clarification. So in order to iterate through this, this is an array of arrays, right? So this array would be array at index 1, and then, or sorry, index 0, index 1, index 2, and then they'd have their own sub-indexes, correct?
Yeah, sure, yeah. I'm not quite sure what you're exactly saying, though, because do you know how to access a number in a 2D array? Let me ask you that.
It seems like not. So this is how I would visualize it in my head. So it'd be an array, and then these are arrays. These are arrays inside that array. If that makes sense. And
no, that's correct. Yeah, that's correct.
Okay. Okay. Cool. Sweet.
So yeah, you just basically have a bunch of arrays up here, array up here, and then array up here. Yeah, and then all these are here.
Okay.
So,
okay. Cool.
So then, what's the issue right now?
That's it. I just was verifying that was the case.
Okay.
Okay. So 0, 1, 2, 3. Gonna do some more thinking here for a second. Okay. Let's just start doing some pseudocoding. Iterate through top layer. Not too different than what we have up there. And then print print value, print current value.
Okay.
And then that's done, or done-ish. So that's printed through. Once we've reached the end of this array, we need to move forward to the next array.
Wait, hold
and
up.
then
I literally just told you. Do you remember what we just said?
yeah. So we're going to the edges.
Yeah, I told you. It's just that, like, the way I described it, I thought it was pretty simple. It's just print the top layer, and then print the right column, print the bottom row, and then print the left column. Right?
Yeah.
So
yeah.
Okay. So how do you do that?
Yeah. So so then we just print second array at last value.
Okay.
And then actually, so I'm still just being too narrow-minded with this one example. So we need to assume that there'd be multiple.
Okay,
so
we're on the step of printing out all the elements in a column. How do you print out all the elements in a column?
I mean, it just allows values of all the arrays, correct?
Well, you just keep the row. You just iterate through all the rows, but you just keep the column static, right?
Yeah.
So
yeah.
What's the confusion here?
Nothing. I just haven't done 2D arrays in a while. So yeah, iterate through column. Iterate through column from top to bottom. And then same thing up here. Print current value. And then when we reach the last, I guess that's assumed. So iterate backward through the bottom layer.
Okay.
Here, print all values. And then now that we've reached the bottom, we'll do the same thing here, but go from bottom to top.
Okay.
Well, so we're not going all the way back up to that first value, so.
Right.
So I would say second to top.
Okay, but there is a better way of doing this, because keep in mind, as you do, if we go by exactly what you just said, we're gonna look at, let's use my example for instance, 1, 2, 3, 4, right?
Right.
And then if we traverse through the right column, we're gonna hit 4, 8, 12, 16. But that means that we hit 4 twice, right? And
right.
You encounter the same exact problem on the bottom, where you hit 16, 15, 14, 13, but you're hitting 16 twice. So is there a better way of doing this?
Yes. So rather than starting, so assuming with this column example, or the first time we occurred the same problem, or the same value, rather than starting at this value, we would start at the next one. And then when we reach 16, same thing, when we switch directions, we would start at the index to the left of this value. Does that make sense?
We could just mark it as visited, right?
Right.
So instead of don't overcomplicate. It's not overcomplicate. I'll talk about it later. But I feel like you're overcomplicating a lot of this shit.
Yeah, I do that.
Okay. So.
Yeah. So.
I'll give you 3 more minutes and then we'll talk about it. But yeah.
Okay. Yep. So we'll move forward with that idea. So we can mark that as visited. Now, that would depend on how we would want to actually do that. We can do that in a hash map. We can also just change the value. I don't like changing the original input. So yeah, we can just keep a map of the values that we've visited by keeping its position in the array. So yeah, so I would have a hash map up here that stores what did I say? Locations that we visited. And then
okay, so then you have a hash map that stores location of what you visited. So, but the thing is that what's your key value pairs?
So the location is going to be the key, and then the value is true. So I guess it doesn't need to be a hash map. It could be a set, and we can just check if our value's in that set.
Okay, how are you representing it?
Good point. Okay, I'm going back to my hash map idea. So key value pair would be the Let's think about this. So yeah.
Are you gonna throw in the towel?
I don't like throwing in the towel, but I'm sure it's frustrating.
Right. I'm gonna cut you off there because I know you're not gonna make any more progress to this problem. So
okay, that's fair.
So let's talk about what happened. Yeah. How are you feeling right now about it? What do you think went right? What do you think went wrong?
Overall, not feeling great. What went wrong? Well, I think the shorter list is what went right. What went right? I think I I did my best in trying to ask clarifying questions. Okay, what I did wrong. For one, I need to work on a few more fundamentals, but despite the fundamental stuff, an actual approach.
No, not in general. Focus on what exactly went wrong in this problem. Don't extrapolate just yet. Tell me what exactly went wrong here.
For the specific problem, or in the actual?
In this very specific problem, what did you do wrong?
Well, I tried to go for more. I tried to skip to an optimal solution without considering a more brute force solution. But even with the brute force solution, I struggled iterating, wrapping my mind around iterating through 2D arrays. Yeah, I would say that's my biggest struggle. And then when it was kind of spelled out for me, I still kind of blocked myself with the original way I was explaining it. Instead of using if I stuck to the verbiage that you were using, which is just go to the right and then go to the bottom, I would have figured out that it was columns. There's easier ways to iterate through columns instead of trying to go down the route that I was going through.
I will say that in general, what I'm seeing is that you are way too focused on the code and details. you are not seeing the bigger picture at all. And I've seen this multiple times throughout the problem. And so let's actually go through the timestamps, and then we can see how it leads up to basically this. So, can you see all this? These are my notes.
Okay, yeah, I see
Cool.
it.
So, first of all, when you're asking quote-unquote these clarifying questions, the point of clarifying questions is to disambiguate the problem or to limit the scope of the problem. And in general, I'm okay with it, but I feel like people just overemphasize the clarifying questions, and I think you do this too, because it's just the easiest one. It's the no-effort way of quote-unquote improving, because as long as I ask the questions, I'm fine, right? And I feel like this is the stupidest way of actually improving. Like, if you focus on, like, oh, I ask questions, like, I don't care. You know, I want you to solve the fucking problem.
Right.
And so asking the clarifying questions, for me, when you were asking it, I thought you were just trying to simplify the scope of the problem. But really, what you should be doing is trying to get at the heart of what is intrinsically valuable to the problem. For instance, like, it doesn't matter if it's a square or a rectangle. Why or why not? If it's a square, it's a little bit easier for me to work with compared to like some arbitrary sized rectangle. That's like one of the issues. So in theory, it shouldn't matter. Like in theory, that's exactly what you should be trying to aim for here, if that makes sense. You should be trying to figure out what exactly is at the heart of the problem that I am trying to solve. So that's where this kind of gets a little bit cut off. So that's the first confusion here. The second one, it's the same thing here. Like backwards, forwards, why does it matter? It's like you're just trying to come up with like, oh, if I go 1, 2, 8, and then I go all the way into the first array, and then let me try going backwards on the first array. You were overcomplicating the exact situation. And at this point, you were basically trying to come up with some magic bullet solution in order to try and solve the problem. You thought, oh, if I throw like some random arbitrary iteration over it, it's going to give me a correct answer. And that is not at all how these problems are solved, or how any engineering problem is solved. You don't randomly land on Mars by throwing a bunch of rockets at Mars, you know? You, like, literally think about, like, what is the step-by-step? If I do this, what happens next? Or what is the dead-ass simple way of doing things and then improving on it over and over and over again? And so you, like, when you came up with this hash map idea, I don't understand where it's coming from. Like, it's just like a random idea and a random data structure that you came up with in order to solve what part of the problem. It was randomly. So that's why I had to refocus you at 12 minutes. I'm going to say the first 12 minutes was basically a waste. Like, you didn't really come up with anything. And then after this, you came up with like this weird parent-child relationship. But there was so much hesitation, even though I told you, like, hey, what's the very, very dead simple way of solving this? Just iterate through the top, iterate through the right column, iterate through the bottom, iterate through the left. 4 iterations. You should know how to iterate through a 2D array. If you know how to iterate through a 2D array, that should have been easily, like, solvable. But the fact of the matter that it wasn't, it means, one, you don't know how to iterate through an array, which is basically a, nope, we are gonna fail you. Like, literally, anyone should be able to fucking iterate through an array. There's no excuse. Like, you said you're okay with arrays, or good with arrays, you should be able to iterate through a 2D array. Like, there's no reason why this should not be a case. And so here, same thing, pedantic about the actual details, column row descriptions, etc., etc. And the rest of it is just basically me trying to get you to say, hey, go from the very simple solution to the optimal one. Just like this shit we're doing here. Like, iterate through the top layer, iterate through the next array, last array. This is way too focused on the details. Like, why do I care next array? Why do I care about this? Like, if you just describe, iterate through the column of a 2D array, that's so much simpler. And it describes the exact same idea. And it's also very general focused. Instead, you're like geared towards this very, very specific way of writing code. Like, what I'm feeling from you right now is that you want to directly translate your quote-unquote pseudocode to actual code. So what ends up happening is that you're just going to end up plugging in, instead of like some iteration or general purpose solution, you're just going to write like array 1, and then like 5, 6, and then array 2, 6. And this is like what I think you're trying to gravitate towards. Like manually writing these numbers out. Instead of like trying to do some like general purpose iteration. Does that sound about right?
Yeah, I see what you're saying.
Yeah, so like thinking about this in general terms is going to be the first step. And not to, well, I should say first of all, think about this in a very, very simple way is the first step. So let me show you how to get to the optimal solution. And maybe this will make a little bit more sense. So first of all, the way I would do this problem is I would start off, okay, what's the very, very brain dead solution? And I'm going to write down what I'm going to think in red. So, first of all, I'm going to do exactly that. Okay, I know that for any array, any 2D array of any size, 3 by 3, 4 by 4, I don't care. I need to iterate through the top of the array, the right column, the bottom, and then going to the left side, right? So iterate through top, from left to right. This is the way I would write it. Iterate right hand column from top to down, top to bottom. Iterate right through bottom, right to left, and then iterate through left, bottom to top. This is going to be my pseudocode essentially for it, and then after that, the next thing would be to like take away the outer layer and repeat. This is basically the general algorithm, and I think anyone can understand this. So the question now is, okay, well, what do I then fill in? What are the problems here? Why can't I do this? Well, I can technically do this, but there's a lot of moving parts. Let's try to simplify like all the issues. So if I iterate from top and then right-hand column, I'm gonna be double printing, right? The issue of double printing means that, hey, I'm gonna print out 8. So then like I'm gonna visit, print, and record as visited, and then print and record as visited, etc., 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 and then skip visited, and then just do the same thing here, etc., etc., etc. So you can see here, I've already solved the problem just simply by doing this, right? So
sure.
Now I can take away the outer layer. Okay, so which means that how do I determine my layers? Well, then I need to have a upper bound, lower bound, left bound, right bound. That's how I'm going to take away the outer layer. And then for taking away the outer layer, I'm just going to do a outer bound plus plus, upper bound like plus plus to represent, hey, I'm going to start shrinking from here down to the second array, right? Lower bound is going to be minus minus, left bound plus plus, right bound minus minus. This is the shrinking action. So you can see here, I'm slowly answering, okay, how do I actually solve this problem? Like, how do I disambiguate the problem? How do I fill in the condition? What are the problems that each of these things introduce, right?
Yeah.
And so after that, I'm going to say exit when upper bound is greater than lower bound, which means that, like if you can draw these imaginary columns, the moment they pass each other, I'm going to say, hey, I've already done that, right? And then left bound is greater than right bound. So now I can say for certain this is going to work. Iterate through top until from left bound to right bound, and then from right bound to left bound, top bound to bottom bound, etc., etc. So now I know that running through this and looking at it, I've solved all my issues. I know I can shrink my bounds. I'm only going to go up to the bounds. I'm not going to revisit any of the things that I have seen. And so, etc., etc. And so we generally know that this is going to work. The problem now is that this is kind of inefficient, I mean, it works, and I would generally accept this. Okay, fine, you came up with an answer. But a much better solution to coming up with this is like, okay, well, what is the inefficiency here? Then this is what I talked about in my last few videos. What is the inefficiency? The inefficiency is that I'm writing essentially the exact same code over and over and over again. Because, like, I'm iterating through top, bottom, I'm managing a bunch of fucking variables here, right?
Right.
So the better way for me to look at this is like, hey, every single time I'm navigating, I'm going from left to right, and then I'm going from left to right, and then bottom, and then from right to left, and then top, and then rinse and repeat over and over again. So instead, the way I can structure this is directional. So I can have a directional, like 2D array that represents the direction of the step that I go in. So it would just be like 1, 0, 0, comma, -1, and then -1, comma, 0, and then 0, comma, 1. And the reason why this works is because if I add +1 to my x here, I'm going to go over to the right side, right?
Yep.
And then I'm gonna add another to my right side here. So if I'm starting at 1, which is 0, comma, 0, right? I add 1. 1, comma, 0 is going to be equal to 2, right? And then 2, comma, 0 is going to be equal to 8, etc., etc. And then if I go 2, comma, 1, I should say this one should be a +1, and then this should be -1. See, like, I'm just testing it right now. And this will equal 5, right?
Right.
0, 1, 2, yeah. And so you can see here, as long as when I need to change direction, I'm just going to swap it for the directional movement. And then When do I change directional? Well, as determined by bounds or visited. And personally, I would say visited. So, like, the moment I say visited, because that way, determined by bounds or visited. That way I can eliminate these upper and lower bounds. That way, once I've traversed this 1, 2, 8, and then I'm going to go turn down, down, left, and I'm now at 5, right? On this side.
Mm-hmm.
Now I see, hey, I've already visited 1. So now I'm going to go turn right, which is this thing. Here, right here, right? And then once I've, visited all 4 corners, then I'm going to exit. Right?
Right.
So now that's basically where I'm at. And I'll let you fill in the rest from there on. But you can see here how I was able to go from a very naive solution to a optimal one that's pretty elegant. If I were to write this out, you can see how this would be pretty elegant.
Right.
So you see, like, all I did, the difference between what you did and what I did, and I want you to do this on your own whenever you do a problem, comparing the optimal solution to your solution. Really say at what point did you deviate, and the point you deviated was really like you knew how to I already broke the problem for you. So the first one is really just being able to very simply, in a very generic way, describe how you're going to solve the problem. It could be super inefficient. Nobody gives a fuck because it's your first one. So really get this into your fucking head, dude. Like, every single problem, every single solution that you do is going to be going from a naive solution that is super crazy, super suboptimal, and then improving on it step by step. The only difference between you and some guy who's getting a staff engineer job is that they go through a lot of these steps much faster. The time you spent doing, oh, well, maybe if I do this, maybe if I do that, how do I iterate through a 2D array again? He's already doing that in his head. And he's already skipping all these steps because he knows how to do it kinetically. Whereas you're trying to figure out how to do it to begin with. And these are things that you can practice on your own. So there's no reason why you can't actually achieve that level of speed. So fussing over what does this look like in code does not matter. Notice here, I never addressed the code at all. All I did was, hey, I started from a very basic solution that works and then asked myself, what can go fucking wrong? So that's how I came up from, okay, well, this is how I iterate from left to right. And it's like, oh yeah, how do I run out of bounds, what happens if I'm going to double print? What is the problem with exactly what I'm writing? And that's all I did. I just addressed each one of these concerns in a elegant, general, simple way.
Yeah, absolutely.
So what I want you to do and take away from all this is really just get to the process of actually writing down the very basic, very easy solution that you know works. Because if you can see the problem and you can see the solution and you can solve it in a general way. Just even with very simple language, very simple, it doesn't have to be super generic like this. It could be a little bit crazier, but at some point, you will get to this point. You will think, okay, how do I improve on this solution? And then be able to say, oh yeah, all I'm really doing is iterating through a column, And then you can just write that in general. And then after that, you just rinse and repeat the exact same process.
Yep.
So, with that being said, do you have any questions so far?
No. No. I need to rewatch this. That was fire. What I got most out of it, was the starting from the outside going in kind of approach, where you were just very general in the beginning, and then watching it transform to you finding the problems with each piece of that basic logic.
Mm-hmm.
Was awesome. I see that was definitely a blind spot. I see how I was going way too far into the weeds and being very specific, which kept me from seeing the bigger picture. So yeah, that was sick.
Good. So when you watch this replay, I really, really want you to think about how to go the gaps in your thinking. And this is an exercise I want you to do for every single problem that you do. When you look at a problem and then you don't solve it, or you solve it and you feel like it could have been done better, look at the steps the optimal solution takes. And then diff that between your approach. Where did you deviate? What was the thought that you had that went nowhere? How do you eliminate that thought, etc., etc.? And we'll talk a little bit more about this later. But the video I uploaded last Thursday, I want you to watch that and try to do that same process with your own problems in the future. But for now, what I want you to focus on for this coaching session, really start with a very simple problem and a very simple solution, and then iterate on that. And to address one of the questions that I got in the chat, why is this like such a common problem to be asked in a lot of different tech companies? Because this filters all the people who cannot logically problem solve. This doesn't require you to know any crazy data structures or algorithms at all. No one needs to know like a red black tree or anything like that. You know, like you, as long as you know what an array is, congratulations, you can solve this problem. So this just weeds out all the people who throw like fucking hash maps and trees at a problem in order to try and solve it. This is a great filter problem. It's a great, like, you know, like those like filter courses that where they like badger and haze the shit out of you by making you do a lot of work. It's essentially the equivalent of that. So with that being said, let me give you another problem. Sorry, go ahead.
Okay. No. Yeah, I was just gonna say I would definitely have gone filtered. So glad we're doing this.
Okay. Yeah. So let's see now. You said you're okay with recursion, right?
We'll see, but I'm down. I'm down with whatever.
Okay, sure. So I'm going to give you another problem. We're not going to use the timer this time. But again, I want you to focus on starting off with a very simple, very basic solution, and then working your way up. Understanding what is right with it, what is wrong with it, why it's inefficient, what are the problems you're running into. But being able to take that first step of solving the problem is going to be important. So for this, let's actually... Okay, new problem here. So take your time, practice what we're talking about.
Okay.
So I want you to compute a valid IP address from this. So what do I mean by this? Suppose that I had an IP address and all the dots got garbled, got removed, right? So I have this 190.168.122. This could be a bunch of different IP addresses. 190.168.1.22 or 12.2 or 190.168.122, 190.1 and then .68.122. These are all the different ways of representing an IP address that could correspond to this string. So what I want you to do is, given a string of these digits, I want you to output all the possible IP addresses that we can have.
Okay.
Go ahead.
Okay. 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 Let me think about this for a second. Okay. So, give a string, I'll put all the possible IP addresses. Okay, so can you describe to me what a valid IP address, what are the requirements for a valid IP address?
Sure. So for each one of the elements within there's going to be 3 dots, right? And then between each dot is going to be the number is going to be valid between 0 and 255 equivalent.
Okay. 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 So I'm just parsing through my head which or hold on, I'm getting some feedback. Can you hear me?
Yep.
Okay. Yeah, I was getting an echo. Okay. So all right, so between each dot is between 0 and 255. Okay. So
So again, let's focus. I want you to really focus on what is the dead ass simple way of solving this problem, like the most fucking smooth monkey brain thing you can think of.
Okay. Just for clarification, just so I know I'm understanding the problem. So these aren't all the solutions that are possible with this string, correct? Or not string, but this input.
I mean, I think it is. I mean, I could try going through the problem myself, but yeah. How about this? Just like these could be all of them, just for the sake of these are just examples, really.
Okay, so this is what I'm thinking. So the reason I asked, so I see on the left, 190 is between that range of 0 and 255. But why can't 1 be the start of it? I mean, I know IP addresses don't do that, but
I mean, it could be, but then you have you need to fill in 3 dots, right? You need to have 4 sub addresses. So how does that?
Gotcha.
So if you try that, what would happen?
Gotcha. Yeah, I see where that would cause an issue. So yeah, 9. Then we have 9. Yeah, that number wouldn't work. Okay, so let's think of some smooth way or smooth brain way to do this.
Mm-hmm.
So I want to look through this value. Can I assume it's a string?
Sure, why not? Yeah, it's a string.
Oh yeah, this is a string of digits. So I'm looking through it, and this first value is between 0 and 255. So we can put a dot there. Obviously, my brain knows this doesn't work, but we'll just keep going. 9 fits, boom, and then 0 fits. But as we keep going forward, we'll see eventually that it no longer meets that.
Sure.
So we would break that iteration.
Okay.
And then I'm not gonna think of the optimal solution here, but
okay. So you came up with 190, right? You put the
right.
3 decimals there, right?
Right.
And then you saw that didn't work. What is the next thing
Right.
to do? Like, what is in your monkey brain world? Monkey world? What is the next step?
So once I figured out that it doesn't work, I would go backward or backtrack.
Okay.
And then remove this dot, and then move this forward and try this next dot, and see if that works.
Okay.
We'll see that doesn't. Go backward,
Mm-hmm.
and then we'll have to keep backtracking, and we'll see that this number doesn't work.
Okay.
So then we would have to go all the way back some more.
Okay.
901 is what we'll end up with. Actually, no, sorry, 90. But then eventually that's not going to work either.
Okay.
We'll backtrack till we get all the way back to this first digit. Then move forward and then keep trying that same approach until we finally reach that first. Well, we don't know it's the first. So we got 190. Keep moving forward, doing the same checks.
Mm-hmm.
That's not going to work.
Okay. You get the idea. I get the idea. Okay. So
Yeah. Okay.
You're effectively what you're doing is trying every single fucking possible combination of where the dots can go. Effectively, right?
Right. Yeah, that's a simpler way to put it.
All right. So let's ask ourselves, what is the inefficiency? What is I mean, it does get us a solution, right? But the question is, why is this not the most efficient?
Why is it not the most efficient? For one, we're going through the array more times than we need to. Or why do I keep saying array? I'm thinking about the last problem. We're going through this input more times than we need to. And let me think. I mean, yeah, to sum it up in layman's terms, we're going through it more times than we need to.
Yeah. That's it. Yeah.
Yeah.
It's just like we're just having a bunch of like random garbage tests that we don't necessarily need to do, right?
Right.
Okay. So then, how do we want to do this in a more structured way that we don't test things unnecessarily?
Good question. Let's think about that. So we have found that starting at the end and going to the input multiple times isn't working.
Okay.
So one thing that comes to mind would be I'm not sure if this is going to work yet, but the first thing that comes to mind is start with the first three digits. And then
Okay.
let's think about this. No. Okay, so what I was thinking was the first three digits, if these three work, then we can check the next three digits.
Okay.
Then we would have a digit that's missing. So maybe it would be the next two digits and the next one digit.
Sure.
But this feels more like just throwing things at the problem rather than having an idea of why I want to move forward with that idea.
Mm-hmm.
So,
let's think about this a little bit more structured, because it does parse out a lot. It does accomplish what we were the inefficiency and strip it out. Like, we're not trying a bunch of random shit anymore. We're actually trying to do things in a structured way. But that being said, we want to be able to place these as strategic positions. So you are onto something. So the question is, how do we make this approach more structured?
Okay, something kind of clicked. So what it seems like with the previous approach, we would have to go back too many times. I need to think of which direction we no longer need to check because we've already checked those spots.
Okay.
So what does that look like? Well, let's look at the examples. So it seems like 190 had already worked. 190 had already worked. And it seems like the problem was solved by figuring out that if we continued past a certain point, that we would know it would never, anything before this point would never be able to keep that valid IP address.
Right, but that is after the fact that you tried it in a bunch of other places after that, right?
Yeah, you're right.
So it's like that part that seems unavoidable.
Right. Okay. Okay. You're right. Let's see. So I need to think of a way where we aren't redoing what we've already done. Or at least cut the problem down instead of looking through it multiple times.
Mm-hmm.
So let's see.
Well, like I said, you only know that you need to grab the first three digits after the fact, after you've tried every single other thing after, like after grabbing one or two digits, right?
Right.
So, can you actually code? So those attempts seem to be unavoidable.
Right.
So then, can we code that? Can we do this in such a way that it's a little bit more generic?
Wait, generic in what sense?
In a sense that we can reuse that logic. Like there's only
Oh.
a finite number of steps that we need to do here, right?
Right.
So the question is, can we encapsulate that general idea that we can just repeat it over and over again until we've completed all the steps that we need to do?
Yes, but I'm thinking of how I want to do that. Okay, so it seems like this problem lends itself to recursion.
Okay.
Because this looks like a kind of like a branching tree that I usually imagine recursion looking like. So it kind of like spreads out this way from the top left to the bottom right. So how would we think about that stepping through it? So
Okay, let's set recursion aside for now. Let's actually think about how to do this iteratively.
Okay.
So if I told you to do this iteratively, how would you do this?
How would I do this? Okay, so we have 3 dots that we need to place. I'm still thinking of the brute force way to do this. So iteratively, I would iterate through the this string here, and then have 2 nested iterations that are kind of ahead of this first iteration to see if where we're at meets the requirements for a valid subsection of an IP address.
Okay.
So I'm just going to write these out just so I can visualize it a little bit.
Okay.
Iterate.
Sure. So the question is, you're going to iterate. What are you going to iterate over, and what are you going to do?
So I'm iterating over the string of digits.
Okay.
And then what I am doing, I am placing a dot. Oh darn! Oh, are we mutating the string here? Maybe we're building a new string, but I don't think that part's important yet. So, just generally speaking, we're placing a dot in front of the index that we're currently at, because obviously we're not going to put it in the beginning because nothing. That's not a value. To the left of it isn't a value. I mean, so iterate and place dot. And then we were going to need to do a check to see.
Okay, when you say place dot where?
In the front of the current index.
Okay.
So, and then, so my previous idea was to have each of these iterations be just in front of each other to start off. So let's do XY. Yeah, so 190 is where we're currently at.
Okay.
Okay. Interesting. Okay.
I think you're losing side of the objective here.
Huh? What was that?
you're just losing sight of the objective here. I think you're just trying random things again.
Okay.
So let me clear things up for you. Based on what we talked about, remember how you said we only could tell that we needed to grab the first 3 digits after trying a bunch of other things beforehand, right? Not trying the first and second, right? So
Right.
Since we know that we can only have 3 digits at most, because, having
Right.
4 would probably mean that we're at 255 or some shit. That why don't we just try grabbing the first, second, and third digit? So try placing a decimal here, decimal here, decimal here as our first chunk, right?
Right.
And then the second one is we'll just do the exact same thing. We grab 1 chunk, 2 chunks, or 3 chunks.
Yeah.
This is what I was talking about when I said do it generally. Like, you could have just when you say iterate, you could just grab 1, 2, or 3 digits each time.
Yeah.
So so I'm confused, like, where you kind of deviated. What was going on through your mind?
It's more of just the tunnel vision. I guess. I I don't know if it's the on the spotness of it, or what, but I keep tunneling down into these paths that instead of stepping away from it and seeing
That's
the
fine.
big picture.
Okay. So let's do a rewind then. So I want you to follow me on this logic, and then let me know if something happens, like where you think you might deviate, right? Okay, let's follow the exercise. So when we started off, you said, hey, I'm gonna try every single possible place that the dot can be. But you also recognized that it was inefficient because you're trying a bunch of different places that don't make sense. So the next thing to do is, okay, well, I can do this more structured. So I know that I need to have 3 dots, right?
Right.
I need to have 3 dots somewhere in this chunk. And I know that all the sub addresses need to be between 0 and 255, right?
Right.
So which means that I know that I need to have only 3 digits, right?
Yep.
Just based off that logic. So I can test 1, 2, or 3 digits for each chunk. 1, 2, 3 chunk, 1, 2, 3 chunk, and then just test to see if this is a valid IP address.
Right.
So that's all I wanted you to get to. And then this iterate and place dot in front of current index doesn't really make much sense to me. And I'm trying to figure out why it made sense to you. What was the idea? I want you to draw out exactly what this idea was supposed to do. Like draw it out on the image or the doc.
Truthfully, it was just throwing stuff at the problem. Yeah.
Okay, I know. Okay, now I know what the problem is. You're doing shit in your head.
Yeah.
Don't do that. Okay. Do not ever do shit in your head when you're this confused. Like, oh, I don't know what I'm doing, so I'm going to just think about it. 90% of the time, that's the wrong idea. Because the reason why, you want to think about it on paper. The moment I drew it out for you, the idea made sense. Like I said, hey, I'm going to try 1 here, 1 here, 1 here, right? And then, I'm going to try 1 here, and then 1 here. And, that didn't work. Like, the moment you drew it out, you were on a roll at the very beginning. And then the moment you choked here was when you started doing shit in your head. The moment I said, hey, let's try 1, 2, a dot here, or a dot here, or a dot here, you clicked, right?
Right. Absolutely.
I want you to do the exact same thing for me. I want you to draw every single one of your ideas. Think about the simple brain dead ideas and then just draw it out. Draw it out and you'll notice something.
Yeah.
Does that make sense?
Yeah, absolutely.
Okay. So we're going to do another problem here. Actually, you know what? How about this? I told you what the idea was, but it may not necessarily click to you. So I want you to carry that idea that I just told you. I want you to complete the problem. I told you the idea.
Okay.
I expressed it. I want you to express it to me again. Make sure you understand it. And then I want you to drive the problem forward from that point on. And understand that each time you get stuck, draw that shit out.
Okay.
So go ahead, do that.
Okay. Let's do that. Okay. I'm going to throw this junk away. I will say, admittedly, that's also part of why I ask a lot of clarifying questions in the beginning. Kind of thinks in my head.
Mm-hmm. Don't do shit in your head. Now's the perfect chance to exercise that and get rid of that habit. Just do it right now. And I'm going to yell at you when you do it in your head. So.
All right. Thanks. All right. So as we discussed, the the most digits that can be in a valid subsection of an IP address is going to be 3. So we have these 3 chunks that are possible. Oops, we have these 3 chunks that are possible. And then within them, we can do look at these sub chunks.
Okay.
So I'm thinking ahead with those first ones. So if we put the dot here, we're looking at these 3 values, and then we can do checks for each of these little chunks to see if they work as valid IP addresses.
Mm-hmm.
And if they do, we can worry about that later. And then with these other chunks, same thing. So we're just doing the same operation on these 3 sub chunks.
Okay.
So what do we want to do with that in order to solve our problems?
Mm-hmm.
So we are eventually we're returning a full IP address where all these values worked out, all these like sub chunk checks worked out. So what are we doing with that information? So yeah, let me draw this out of my head, or not in my head, but out loud. So if we're looking at this first subchunk, we have 1, 119, and 190, and then 1. Sorry if this is verbose, but I just need to visualize it. Oops, 16 and 168, and then finally we have 1, 12, and 122. And so, just for visualization's sake, if I were to build out this substring,
Mm-hmm.
or sorry, if I were to build a string with these results,
Mm-hmm.
what does that look like? So, what does that look like? So returning 1, right now I'm just looking at the first, the top 2.
Yeah. Here's the thing. Keep in mind. One thing is that when you drop the dot here, then you need to drop a dot here or here or here, right? Because just because you have 1 here, 1190, and then 1168, 122, doesn't necessarily mean that you are going to have that as your second sub address, right?
Right.
So you're not gonna have 111. That's impossible to derive from the string. So be very careful about this.
Okay. You're right. Okay. So let's see. Oh, okay. I'm thinking in my head again.
Draw it out. Start back from the beginning. What is your what is your, like, even write it out if you have to, like in plain English. What is your plain simple algorithm that you're running with?
In plain English, what is it that I'm doing? So yeah, let me write it out.
Yep.
Computing sub chunks.
Okay.
To see if they're valid. Given a string of digits. Okay, let me redo this to make sure. So we're computing the subchunks to see if they're valid. What do we want to do with that information?
Okay, but that's the plain English. But then now let's get a little bit into details because I think you're getting. This is the part where we're actually going to start pivoting into it because last time you were thinking too much about it. Now, what do you mean by computing subchunks? Let's dive a little bit deeper into that.
So what I mean by computing subchunks is to see if these little pieces, these subchunks of the subchunks, if you will, if they meet that prerequisite for a valid IP address chunk. But like you said, the fear of that would be returning 1.1.1, which obviously we need to use all the values that are here.
This is the wrong idea. Remember what we said before? 111 is wrong.
Right. So I think the problem is the way I'm visualizing it is top to bottom, and it's ignoring what's left.
The thing is that each of these, where you put the decimal, has an implication and affects how you put the next decimal, right? Like I said before, if I put the decimal here at 1, right? Oh wait, my keyboard is disconnected. If I put the decimal at 1, that means my next subchunk must begin with a 9.
Right.
So that's inescapable. This is a wrong idea, by the way.
Okay.
So, like, if I put a 1 here, I have to put my decimal after that. I can't just, like, willy-nilly put it here, because then, I mean, I could, but then I have a chunk here, 901.
Right.
So, I get the feeling you have the wrong solution. So, let me actually, how about this? If I do the solution for you, let's see if you understand it, because I still think...
Okay, actually, sorry. Give me one more shot at it. Give me like 60 seconds.
Okay, you want one more shot?
Yeah, so
right.
You deleting that actually clears things up a little bit. So,
okay.
So what we can do is, oh man, I just had it. So, just gonna write this out so that I can not forget about it. We're building potential string, and then oh man, it like clicked for a millisecond. So like you said, so this wouldn't work because I would need to put the points like that, and obviously that doesn't work. But if we had it at 90, never mind.
Okay.
Just yeah, go ahead.
Okay, so I'm going to do I'll show you the problem, and let's see if it makes sense to you. So I'm going to do it here. So I'm going to grab the first 3. The way I'm going to do the algorithm is I'm going to grab the first 3 chunks, 3 digits.
Okay.
0 digits, 1 digit, or 2 digit. It doesn't, or yeah, digits are actually I say 1 or 2, 3, 1, 2, or 3 digits. So let's just say I grab 1 digit right here, and then do that 3 times. That 3 times for every permutation, right? So I can grab 1, 9, 0, and here, right? So I've grabbed 1 digit each time, right? And then check if valid IP address. If it is, add it to our list. And then rinse repeat, right? So let's say I'm going to grab my since we're doing it 3 times, the first time I'm going to grab just 1, right? Second time I'm going to grab 9. And third time I grab 0. And then we just check to see if this is a valid IP address. It's not a valid IP address, right? So then now I'm going to backtrack, and it's like here I'm going to have 1, right? Place the decimal here. Not valid IP address, right? Grab the third digit, 6. Not a valid IP address either. So okay. So then now we're going to backtrack to 2, right?
Yeah.
So now I'm gonna bump this up over to 190, right?
Yep.
And then 3. And then now we have to do that third loop again, because these are subsequent loops that are done inside each other, right? So we grab 1 chunk here. Not a valid IP address. Okay, let's move on to 16. Not a valid IP address. And then 168. And then 168, right? Oh, this is a valid IP address. So then we add this to our list, which is going to be 190.168.122. Boom. We have our first element in our list, right?
Right.
And now I'm going to do 1901. Well, now I know this is. I mean, I could continue on, but we can already tell that this subset is not going to be a valid IP address, right? So we do those optimizations as well. So you get the idea now. And notice here, all I did was just walk through it.
Yeah.
And so now, I mean, I can do that. I can keep going forever, you know, like 1.90, and then the second loop I grab 0, and the third one I grab 1, right? So rinse and repeat. But this is what I want you to do. Like when I said draw it out, I wanted you to draw this entire sequence out. Actually, I wanted you to work through the problem. Like you see here, I have my little pseudocode. It's not completely the nicest pseudocode in the world, but you already understand what I'm trying to do. And the moment I illustrated and walked through the entire thing, like step by step, you instantly got the idea. This is what the point I want to get to you today. I want you to be able to do this. Walk through your own idea.
Yeah, it's a huge. That was a huge blind spot.
Yeah. So again, it's the same thing we did up there. It's like I want you to walk through your own simple idea. I mean, we addressed like, okay, now you are going through the simple solution. You were starting off pretty good in the beginning, but then you choked here because you're trying to do things in your head. Draw this shit out, man. Draw this shit out.
Yeah.
Okay.
I think where I struggle is like how to properly convey that to the user, but I mean, it makes so much sense now that you've done it.
I want you to copy this. Go ahead.
No, yeah, go ahead.
I was gonna say, I want you to copy what I'm doing. Like literally, this fucking exercise. After this coaching session, do exactly this. Do this exercise of, hey, this is how I'm going to express my idea, and walk through walk through the steps and just be able to, draw out what the hell you're doing. Not explaining it. I don't care about all this yap shit. Because all your idea just stays in your fucking head. The moment you draw it out, put pen to paper, it makes so much more sense.
It does.
Okay. Any other questions?
I think where I don't want to say it's a misconception, but where I deviated from the proper way to do it is the way I was seeing communication was just talking out loud what I was thinking in my head, but actually like putting it on the page, the actual process, that makes so much more sense. How that like proper communication and like problem solving. So no, that's it.
Yeah, like, I mean, if you are just talking for the sake of talking, that's not communication. You're not conveying any idea to me. You don't even know what you're saying. That's, being able to communicate like that means absolutely fucking nothing. But being able to actually understand your idea to a point that you can draw it out and you actually understand what the hell are the words that are coming out of your mouth, that's completely different. I mean, don't get me wrong. There are plenty of people who fucking talk and have no idea what the fuck they're talking about, even at, like, fucking senior staff level. It's just like, we would never want to hire them if we could prevent ourselves, So don't be that guy. Be able to actually understand what the hell you're doing,
For sure. Yeah, that makes a lot of sense.
Yeah. Plus, like, the added benefit of doing this, of drawing it out, is that the interviewer might be, like, lost with all your words, but the moment you draw this shit out, it's like, oh, well, now we have a record of what you're doing, and I can visually see what you're doing. Like, a picture's worth 1,000 fucking words.
Right.
So.
Yeah. For sure, and I think an important takeaway for me is I have this obsession of if I want to draw it out, I need to assign it to like a data structure or some algorithm. But literally just writing it out makes it so much more clear. And then I can work, and then by writing it out, you can kind of visualize what data structure you would want to use anyways.
Yep. So okay, with that, we're gonna do one more problem, all right?
Let's do it.
All right. This one's gonna be easy, and it's designed to be very easy so that you can practice everything that we talked about. And I want you to do exactly what we talked about. Start with a simple solution, understand what makes it inefficient, and then be able to just go step by step through that, and then come up with an optimal one. Okay?
Okay, let's do it.
It's not. Yeah. No, let me pull it up. This is one. Oh yeah, you can't do tree problems. Damn it.
I mean, I could give it a shot. I mean, I've done tree
No,
problems.
I want to focus on what we've talked about today. So.
Okay.
Okay, yeah, this one's fine. This one's fine. So what I want you to do is I want you to delete duplicates from a sorted array. You might have seen this problem before, but it is relatively easy. But again, focus on what we're talking about today. So you see these. So you can see like I'm giving you an array 1, 2, 2, 3, 4, 5, 5, 6, right?
Right.
Your job is to remove the 2 and the 5 from a sorted array. But you're not supposed to have any more duplicates. So.
Okay. Okay. Let's do it. So in JavaScript, I'll just add it to a set and we're done. I'm just kidding. All right. So big picture, let's think of the most naive ways to do this. So I want to pass through this array, or iterate through this array. And in layman's term, we want to pass through it and check to see if we've reached, or if we've seen this value before. And if we have, we want to remove it from that array. And then once it's removed, we move forward, basically keeping track that we visited it. And sorry, if we haven't visited it, we record that we have. But if we have visited already, we delete it. So let me kind of draw that out. So the most brute force way to do it is to do 2 passes. When we hit that first value, we're going to check every value before it. Or sorry, we're going to check every value after it. And compare it to the one where we're starting. So we pass through the array, we see that 1 doesn't exist. We move forward, and then we see that 2 does exist. So what do we want to delete? We will delete the y. Sorry, we'll delete the value at the iteration that is ahead of the first iteration, and then move this value forward. And then we'll just do that continuously until we've deleted all the values. If that makes sense.
So when can you delete an element when you have an array? An array is just a block of memory, right?
Right.
So what exactly does delete look like to you?
What does delete look like? So let's think about this. I mean, the most hacky brute force way to do it would be to, rather than delete it right now, we would move forward 1 and then kind of swap these, if that makes sense. So this would be 3,
Sure.
This would be 2. Actually, rather than swapping it, we'll just move it to the end of the array. Okay, no, I'm just throwing things at the problem.
At the end of the array, so what are you gonna do?
What was that?
You don't have any space in the end of the array, so what are you gonna do?
Yeah, this is more of just throwing stuff at the problem.
Sure. Think logically about this. You said you're gonna remove it, right? You have 2 pointers. You're gonna remove shit. So, how can you do that? Let's put it that way. In fact, let's put it this way. What do you imagine your solution to actually look like here?
Okay. What? Am I mutating the original array, or can I create a new array?
I mean, let's say for now you can do. Let's create a new array. Like, it's fine.
Okay.
But I will say there is a way to do it in place, but don't worry about that. Like I said, monkey brain solution, man.
Okay. Yeah, this is a problem that I've done a million times, but for some reason when I'm on the spot, my brain just freezes. What are we doing here? So back to the, just to solve the problem, back to the,
just solve the problem right now. Draw it out.
Back to the solution of where we're building a new array. So as we're looping through, the first value is always going to be added for now until I see an issue with that.
Okay.
And then we can do a check on each pass. Wait, what does each pass mean?
Simple solution, man. So what is the simplest, easiest way you can do this?
Man, locked up. In layman's terms, look through this array.
Okay.
And then on each spot, raising my voice is making me smarter. All right. On each spot, look through the rest of the array and see if we have a value that.
Okay. Do you know what a hash set is?
What was that? Yeah, I know what a hash set is for sure.
Do you think that can help you here?
Yeah, for sure. So I know that's the optimal solution, but the solution, but I'm trying to go through your, like, drawing it out logically rather than.
Yes, you can draw it out logically, but you need to also understand what the naive solution is, and you know that the naive solution is to throw everything at a hash map. Right? You understand this, right?
Yeah, I do.
So I mean, it's like you could have just started off with that.
Right.
Like you understand. You understand. You could have done that. So just throw everything into a hash map, return that goddamn hash map, and that deletes all your duplicates, right?
Yeah.
Do you need to draw it? Do you need to draw out the process for what hashing looks like in a hash map or a hash set?
No.
I mean, you could, and don't get me wrong, but it's like I would have liked for you to actually say that solution, but okay. So that's fine. So what is inefficient about that? What's inefficient about using a hash map? I mean, a hash set.
Well, for one, it's linear space.
Mm-hmm. Yeah, we're using extra space.
Yeah.
Okay. So then the question is...
Well, we can do all this in place.
Yes. We can do this in place. So that's all you needed to say at the very beginning. You should have... That's what I'm talking about, like, acknowledge the original solution. Even though it might seem like some fucking random shit, you know? Like, it's important to recognize and acknowledge the simple solution. Even if you might not do anything with it, just acknowledge that it exists. So, that being said, which means that in order for us to do this in place, in order for us to use, like, not any linear space, we need to do this in place, right?
Right.
Okay. Now, let's pick up where we left off then.
Okay.
Hello?
Yeah, I'm here. My brain's just locked up.
Okay, your brain locked up. Let's unlock it. So, why does the hash set solution work? Let's ask ourselves this. There's something about it that does work.
Right.
Why does it work? Hello?
Yeah, I'm here.
Okay. Why does the hash set solution work?
Because it allows us to be able to track the items we've already seen.
Right. Now, we're using extra space to express that idea, correct?
Right.
So, can we express that same idea without using extra space then?
Yes.
How are we going to do that?
How are we going to do that? So, we can have pointers,
Mm-hmm.
and the forward pointer would be.
Why do we need 2 pointers?
Because we're keeping track of 2 values.
Why 2 elements? How'd you come up with 2?
Because at any given time, we're only comparing 2 items at once.
Okay.
And then moving forward, I plan on, once we do have a value that hits that breakpoint.
Okay. So right now you're comparing 1 and 2, right?
Right.
Okay. These 2 are not the same. So what are you going to do?
This is all obviously assuming that the array is sorted. So 1 and 2 aren't the same.
Mm-hmm.
So we move that forward.
Okay.
We move the first pointer forward.
Okay.
And now we always want to have that second pointer in front of first pointer.
Okay. So you're moving both pointers up 1.
Right.
Okay. So now these 2 pointers are pointing to the exact same element. What do you do?
Well, we know we want to delete it. Well, what does
Okay.
that mean? How do we want to delete it?
Mm-hmm.
How do we want to delete this? Well, we know we want to replace its position or the value in that position with the one in front of it. If it doesn't match 2 in this instance, so we can, like I just did, we can move that pointer forward, and we would want to if there's multiple duplicates, it would just keep going. So if it's 2, 2. But I mean, really, we're just replacing the one in front of it for now, in front of the first pointer. So that is okay if we have duplicates or multiple duplicates.
Okay.
So we've hit a point where in the second pointer we have a value that doesn't match the first pointer. So we can assign the value in front of our first pointer to be that value at the second pointer.
Sure. That works.
And then we move the first pointer forward, or actually, yeah, we moved that first pointer forward now that those two elements don't match.
Mm-hmm.
And now, as we see here, these two match, so we're going to do the same operation. Move forward, replace as soon as we hit that breakpoint, and eventually we're going to hit a point where we have hit where 5 is the last element, and then we reach the end of the array.
Mm-hmm.
And now all we're doing is returning an array with all the values of the original array up to that first pointer.
Sure. I mean, the idea is rough, but you pretty much got the idea, yeah?
Yeah.
Yeah, you pretty much got the idea. Just literally, and all we did was literally just walk through it. Just try to say, hey, this is what worked in the previous solution. In the naive solution, how do we make it work in the optimal one?
Right.
So, do you think you would have been, like, let me ask you, this last problem, do you think you would have been able to solve it on your own?
Like, yeah, for sure.
Okay.
Yeah.
All right.
But that's the issue. It's that I can only do it on my own.
Well, that's okay. But anyway, so you were able to do this problem, and you were able to do it like from a more like grow the solution perspective. So do you feel like that made it easier than if you did it on your own, or harder?
Say that again.
Do you feel like this made it easier or harder for you? You can be honest, man. Like, if you felt like it was harder, then let me know.
It's not so much that it was harder. It's that I'm drawing it out. If that makes sense.
Mm-hmm.
So it's easier when doing it with another person.
Mm-hmm.
But I think the drawing would have been done in my head. If that makes sense.
Right. So if I can break that one habit of you like doing shit in your head, and you making you do it on paper, I think I think that we got a lot. That's it. Like just breaking that one habit is 1 or 2 habits is gonna be good enough because there's only so much I can do in 2 hours, right? But if I can get you aware of like these bad habits you're doing and begin to break them for you, then I've done my job. This is the way I see things. So with that, let's recap what we did here, and so that way we can write down what exactly you need to do going forward. So the first one, you did the spiral ordering, but you got caught up in your own head. You kept trying to do like some weird ass magic bullet ass solution for no fucking reason. And then after that, we tried emphasizing, hey, just start from the simple solution, take what works in the simple solution, try to keep it, and then acknowledge what is inefficient, and then strip out the inefficiency and build up the solution. So we did that here as well, and then we said, for the IP address to say, hey, you need to draw shit out at every single step. And then you're able to actually come up with the idea just by drawing it out in about 10 minutes, actually. Like, this part only took you 10 minutes to come up with the idea. So, So, with that, let's actually talk about, like, how you would want to practice going forward. Because you will be on stream Thursday, and we're going to review your studying. So, I want you to not... And I mentioned this before, like, if you saw the video that I uploaded last week of how to actually, actually study and practice and compare your mistakes. So let me actually show you the practice diary, and I'll send you I'll make you a copy as well. But essentially, the way I would record today's lesson would be like for the first solution, I would say what went wrong was I was not able to. Like comparing it to the optimal solution that I showed you, or at least the beginning, I was not able to solve the problem because I tried to magic bullet the solution. Instead, I should try to solve the problem naively, and then fix the problems with that solution, and then extrapolate and then solve it in a general manner. From there, I can grow and optimize my solution, and I would need and I need to be more comfortable with iterating through a 2D array. So this is the way I would be re-recording, like, hey, this is how I fucked up. Here's what I need to do to resolve it. And then I need to be more comfortable with doing a 2D array. I should have seen how to do things more generally. So once I do that, what I'm going to do is I'm going to put this into a practice diary. So I'm going to say here, let me actually share with you my screen. People on stream can actually see the document, but let me share it with you. Hold up.
Okay.
Where is your Discord? Here we go. Cool. Perfect. Cool. Can you see this?
It's loading up.
Cool. Yeah.
Okay, yeah, I can see it.
Great. So let me delete rows. Cool. All right. So then, yeah, let's just say delete rows. So say it is 8:24 or something like that, and it took us like let's say it's about like what 8:30 to 9:30. Let's say 9 o'clock. So it took us 30 minutes to do it. I would say it's pretty difficult for you and we'll call it the 2D spiral problem. The approach was 2D array iteration, and then I would copy paste this that we've written here over to here, literally as a practice diary, and then be able to say, hey, what went wrong, what went right, what was the insight I needed in order to actually do this problem better. And in this case, what you need to do is be able to see things more generally and draw things out. And I want you to really repeat this exercise for the second problem on your own. I'm going to give you the link to this practice diary.
Sweet.
I'll give you a view so you can make a copy of this on your own. And this is the way I want you to practice. So the next time I see you, what I want you to do is to record yourself doing a problem, like and kind of like the same way we did it today, where we talked through how to do it as if I was there. I want you to time yourself. I want you to like speak aloud, right? You got it?
Yeah.
Time yourself, speak aloud, and then record yourself with OBS or something like that, because we're gonna watch it together on Thursday. And I want you to like write it on Google Docs. I know this might seem like unnecessary, like, oh yeah, you're used to writing things on pencil and paper, but I want you to. But the thing is that when you do these interviews now, you're gonna do them on Google Doc anyway, so you might as well get used to it.
Okay.
So, I want you to do this like last thing Wednesday night. I really want you to try practicing what we talked about tonight. Do it tomorrow, and then maybe like if you have time on Wednesday night, the last problem you do, I want you to do this.
Okay.
All right. And then really try to practice the things that we talked about. So acknowledge the simple solution. And then the second one is to optimize on the solution over and over again. Acknowledge the inefficiencies. And the third one is to draw that shit out. Big one. Like, don't do shit in your head.
Right.
So, if you can do these three things, I don't expect you to do it by Thursday. Don't get me wrong, but I expect you to like practice this. So, if you feel like by like Wednesday night, just like, oh, I need more practice, we can push the review out to like Saturday or something like that. Give you more time to practice on it. So, but just keep me posted, okay?
Okay.
So, we have like 3 minutes
actually,
left.
hold on.
Go ahead.
Let me. Yeah, it's my girlfriend's birthday on Thursday, so I won't be able to do Thursday night. But I can do Friday night or Saturday night.
Let's aim for Friday night then. But yeah, I want you to take this like pretty seriously. I want you to treat this as if it's a part-time job. I want you to spend at least 8 hours practicing what we've talked about tonight, if you can. So.
Oh, I can. I will for sure. Okay. So questions before you go. In the diary, am I sending that to you, like just giving you an invite so you can track it, or is it more so for myself?
Both. By the time I see you on Friday, I want to see your record of the problems that you do. I want to see like the effort you take to try and diff the problem between the optimal solution. I want to see like every single step you do, how you're tracking your own progress, and if you're making the same mistakes over and over again.
Okay, and then for the recording, just with like a random leak code problem, or do you want to see like something I've done before or haven't done before?
I want you to do like preferably something that you are how to say, that you feel like you could do. And
Okay.
I want to see like it could be elements of programming interview, it could be leak code, it could be whatever. But I want you to do one that you feel reasonably comfortable with, because it doesn't make sense for me to review a replay where you just end up flubbing because you don't know how to, do dynamic programming or some shit,
Right.
I want
Okay.
you to be reasonably comfortable with it.
Okay. Comfortable with topics, but doesn't necessarily have to be one I've seen before.
Yep.
So I'll probably take something from Graphian. Okay. And then do you want that sent to you like much meeting, or I'll just send it to you when we do our meeting?
We'll do it when we do our meeting. So yeah.
Okay. Cool.
All right.
Sweet.
Any other questions?
Nope. Truthful. This was I needed this, so I appreciate it.
Yeah. All right. I'm glad you found this useful. Take care, man. Practice this shit. Let me know how things go.
Thank you, sir. Take care.
All right, for sure. Take care, man.
Bye.
All right, bye. All right, cool. So let's actually see what you guys said in the chat for a hot second before I move on to the next thing. Live stream. Let's see what we got. So, Traco says, my face. Yeah, I did have facepalm there. Hire me to be a staff. I'm freaking mid-level and I got a graph problem as first round. Bro, like, are you asking for a job or something? Like, what do you mean hire you to be a staff? I don't know. But yeah, the way to solve this problem was basically to overwrite the previous value or swap it forward. And I think he did okay here because he was able to actually derive the basic idea just by walking through it. So, and that's kind of like the point of what I was hoping that he would do. Like, notice here that we didn't do anything with code. All we did was like really focus on the fundamental of solving the problem, So really, just if he's able to do this, I'm okay with the way the session went, and I'm hoping that he pushes it a lot forward to when I see him next time. So, extra space, yeah. You're referring him leak code. Why not EPI? EPI is fine. Leak code is fine. I personally think that EPI is better. But I just mostly just want to get into his head the effort or the exercise of being able to do this, being able to go through the whole exercise of correcting his own mistakes. So at that point, leak code or EPI is going to be good. Once you get a little bit more into it, then EPI is going to be much better. So, how important is actually writing a complete block of code during an interview? I would say pretty important. If you can't finish off writing the code, then you haven't actually solved the problem. But everything we're doing right now is the setup to writing code. If you can't understand what the fuck you're writing or what you're writing about, there's no point, Like, you need to have a solid idea before you write code, because code is a big ball of mess in and of itself. It's a liability because you have to maintain it, write it, debug it, all that shit. So if you have a clear idea going into writing the code writes itself. This is the philosophy that I really work with. So with that, let's actually bring Mr. Staff Engineer on. Hold up, let me message him, see if he's ready. Yo.
Hello?
Hello?
Can you hear me?
Yeah, I can hear you. Can you hear me?
Yes.
Oh, wait, I'm doing an intro for you. Hold up. I don't know if you can hear this.
Yes, I can.
You hear that?
Yes.
Your time is up, my time is now. You can't see me, my time is now. It's the franchise where I'm shining now. You can't see me, my time is now. In case you forgot.
Okay, I just had to do that once. How's it feel to be a staff engineer?
Yeah, feels great, yeah. I don't know, yeah, it was a lot of work and yeah, it feels good, yeah.
Alright, yeah. So say hello to the stream. I guess do a little introduction about yourself, where you worked before. Well, maybe not where you worked before, but where you started from before, where you met me, the whole story.
Yeah, so I'm I can say that I'm located in Europe, and like I finished like not so good, maybe not a perfect university. Somehow I didn't have perfect algorithmic preparation there, but then I joined the company and started working here as a software engineer. And at some point, I realized I would like maybe to improve my algorithmic skills and system design skills to pass interviews. And yeah, this is like around 2 or 3 years ago. I started to look at LeetCode and like this book, cracking the coding interview, and it was pretty interesting. So I started like a hobby, but what I think I was doing, I was reading cracking the coding interview like as a book, as a novel. So I was thinking, oh, nice ideas here, over and there. Yeah, maybe I could use this one day. So I read it like a novel, and then I went to LeetCode. There I couldn't solve anything, so I just doing what I read somewhere on the internet was saying. So I saw this comment maybe on Blind. People were saying, yeah, you just need to memorize the text questions and you're good. So I thought, yeah, if it's the deal, then I can do this. And yeah, I was doing that. And I think this is the point. Yeah, this is the point where I actually was invited to an interview. It was with Microsoft. And to my surprise, I passed it, but it was an interesting experience because basically there was only online assessment, which was coding, and then there was on-site, which was 90% behavioral. So 90% they were asking me like what I have done before, tell me about your project, and there were no technical challenges. Okay, there was small system design round, very small, half of the time, and a coding interview, which was not about writing code, but just tell me how you would solve this problem. And maybe that's why somehow I passed it, but it was pretty like not a high level. I think it was 61. I'm not sure what it is, but the salary was also not so good. And yeah, so I even thought, yeah, looks like I'm doing everything correct. So I'm doing preparation, I'm passing interviews, looks like everything is fine. But then after Microsoft, I had Facebook and Amazon, and I failed both of them. So I failed Facebook phone screen, and with Amazon, I failed the on-site. And in my opinion, it was due to the fact I couldn't solve the coding questions because they were the questions I haven't seen before, and I was totally lost. I couldn't finish the questions, I couldn't solve them. So I realized there was a problem. So this memorization technique didn't work for me. And then, yeah, I maybe tried to continue a bit further with this strategy, but it was falling apart. And this is the moment when I wrote to you, Edward, and asked you to help me.
Nice, yeah. So, yeah, I do remember that we basically spent like about 3 months preparing you for your coding interviews. Yeah, like describe to everyone like your experience with that. How you felt like your whole like how you felt about the entire thing.
Oh yeah. So let me think. Yeah, so it was a pretty different experience. I maybe forgot to mention also that before that couple of months I did some mock interviews, which I thought would also help me on this path. But still, I think for me there was a huge difference between mock interviews and coaching, because in mock interviews, it's like you come to this mock interview, you solve questions. I was doing with the same, let's say, person, yeah, over and over again, let's say every month. But my kind of problem was that each mock interview was like meeting a new person. So my interviewer always started like from a clean page, yeah. So we didn't track progress because it's also my responsibility. It was just random problems from random topics, and somehow, yeah, maybe I was learning maybe some techniques, but I didn't see the bigger picture. For example, I didn't know like how to even like start solving the problem, and that kind of stuff. Yeah, okay, now with the coaching, so yeah, for me it was a bit hard because first of all it broke my time schedule, so the way I plan my day, because yeah, and I try I try to follow as close as possible to your advice and requirements, Edward. So if you say that I need to do it, I don't know, in the times like I don't know after 10 p.m., which is usually the time I go to bed, then yes, I kind of force myself to do it, and so I tried to execute on schedule that we agreed on this document. This was a bit at the beginning, not so hard. Then I realized another my big issue was the quality of work I was doing. And I think it's a very general issue. The ability to concentrate and to work 1 or 2 hours or 3 hours, like without interruption, was a bit hard for me. So, like by interruptions, I mean things like checking social media, checking email, LinkedIn, YouTube, all that stuff. So for me, it was kind of my internal enemy, and how I did it, like how I solved this problem may not work for everyone. So I started basically to record myself. It was just my screen without sound. I was not going to show it to anyone. It was just for me, but it's just to keep me accountable. I just was imagining if you ask me, okay, show me how you prepare what you were doing, I could show you this to you, and then there will be no YouTube videos or Facebook that I really work at this time. So you never asked me for this. This is kind of I invented for myself, but I wanted to keep it like that. And the second, I also joined some website. Maybe I shouldn't name it, but basically, you can also join groups of people that study. So like on the internet, and you can maybe just in a group you can study, prepare for stuff, and exchange experience and do it in a time block manner. So this is how I was doing that.
Gotcha.
So this was about.
Oh, sorry. Go ahead.
Yeah, go ahead.
I was gonna say, like, so one of your biggest issues was really being able to get quality practice in that was like giga focused, whereas before you were just kind of like, you're like kind of splitting your attention between random stuff.
Right.
Yeah.
I think I also read this book, Deep Work, where the author talks it's a common issue now in modern society, and the ability to work for uninterrupted for a big amount of time, like 1 hour or more. It's an important skill.
Yeah. So let's talk about like a little bit of week to week progression, because I know for certain, like at the very beginning, it felt like a grind, but then I think probably around week 5 to 6, it kind of just like all kicked in for you. So describe like the day to day of that. So, like, did you feel like you were constantly struggling, not making progress, like, or the coaching sessions? Did you feel like I was like too brutal on you, or did you feel like you were getting frustrated? Like how did you feel going through the whole process?
I remember the first session was a bit brutal there in the sense. I remember I couldn't solve the problem you gave me, and although I had seen the problem many times before, or at least 2 times, and it just it just a huge a feeling of frustration, because I thought, my God, it's like I don't make any progress. I spent so much time. So before I met it was about 1 or 2 years. And it's all kind of in vain in the sense that I still cannot solve problems. And but what kind of helped me is that you give very clear instructions, like with this homework. I just try to do exactly what you ask, and it's usually not that much. Usually it's 2-3 things. I just really try to concentrate on them and do as close as possible. Like, concentrate on them. I know that there is more stuff, and there are other topics. I know you're telling me to do the stack trace, and of course I realize there are so many problems and they're so complex. But at the moment for this week, I will only do the stack trace thing. This would help me.
Yeah, so you focused on one thing at a time, like one little piece of instruction and feedback I gave you, and then after that, like week 5 and 6, like it kind of all came together. How'd you feel when it first, like when I said, yeah, you're pretty good at the data structure and algorithms?
Yeah, it was actually a good moment, because basically I didn't believe you. So I heard what you said, and maybe I said yes or fine or something, but internally I didn't believe in that. So I thought maybe you just want to motivate me or something, but it doesn't correspond to truth. But then after like again maybe a couple of days of reflection, I said, yeah, okay, like, do I trust Edward? I thought, I think, yeah, I do trust. And what he says, then it also must be true. And I think, yes, because like it doesn't make sense if I don't trust you. Like, why? No, I'm just trying to say. Yeah, so eventually like, I convinced myself because if you believe in it and you have much more experience and you pass those interviews actually, then I should I should also believe that too.
Yeah. And so yeah, I guess like you kind of really saw it when you first did like I think the phone screens, and then there's like they were so easy for you.
Yeah, exactly. Yeah, and even I remember like last year I took Amazon interview. It was 4 rounds on site. I was exhausted by the third because it's just so many thoughts in your head and you don't really know how to solve problems. So much stress, and I was like squeezed like a lemon. But this time there was also 4 interviews. For me it was like just normal talking to people. It was super easy somehow. Yeah.
Yeah, so like the phone screen, the coding interview, everything was just like so easy to do for you.
Yeah. It also somehow it reduces the amount of stress and you feel more relaxed because basically the pattern is before I see a problem, I stressed out because I haven't seen it before. Then I tried to maybe rush to the solution to write code because I read somewhere people say, oh, like you need to start writing code early. So without an idea, I used to start writing code early and it was wrong, and then the time was out. But now, like I see a problem, I have not seen it before. I have no idea how to solve it. Really, like frankly, I don't know how to solve it. But I'm so relaxed. I say, yeah, okay, let's go just through some examples, and then this time, which is when we talk about example, we talk about brute force approach. And this time, in my background, I already start to think about optimal solution, and then I just see it, so to say, from optimal from brute force. Then just start noticing inefficiencies, and then you come up with a better solution.
Right, so the whole approach just became kind of like systematic for you. You weren't like sweating over not seeing the problem. You were just like kind of going through the exact same thing that you had practiced.
Yeah, exactly.
Okay. Yeah, and then since we don't get to talk a lot about like system design on this channel, I think we took like a little bit of a different approach to that. I think mostly it was, well actually no, I think it was like pretty much the same approach. It was like trying to identify inefficiencies, and then I made the point that data structure and algorithm and system design are pretty much the same. Did you feel that was just kind of the same way, or what was your experience with that?
Yes, it was pretty similar. First of all, there is a structure there as well, and if you follow it, it's like for me it's like protection. I feel pretty comfortable with this framework, where in system design you define this functional, non-functional requirements. Then for me it's like even during this process, I already start to think how I would implement this, or in system design, how I would design this. So this is similar, and also the other similarities you mentioned is that you start from basics, and the point here is not to learn by heart the existing architectures. Yeah, maybe it could be good practice just for I don't know to know what there is, but you can also basically build the same thing yourself. This is how I understand it. You can just use the basics. It's like a constructor, and then you can engineer it yourself, and this is what interviewers looks like. They appreciate that.
Mm-hmm. Yeah, they appreciate you like building things from the ground up and really understanding the shortcomings and the flaws of what the system's going to have, and then how you deal with it.
Right.
Yeah. So we covered like your preparation, your system design, and talking a little about that. Let's actually go to the actual interviews themselves. Like your I think you had passed 2 interviews, and then you didn't make the last 2. You did Wayfair and then and Amazon, and you got an offer from both, right?
Right.
Yeah. So let's walk through like the your whole interviewing experience. Like what did you felt like you did good on? What did you think you could have done better? How I could have helped you done better? And all that sort of thing.
Yeah, with good part. Yeah, I think yeah, I enjoyed coding exercises or coding questions in those companies. So I think I did them pretty well. What I think I noticed maybe interviewers like is some problems have several solutions. I remember at my Amazon interview there was some question about it was, I don't know, you can solve it with DFS, you can solve it with BFS, or you can solve it with some other traversal. And then by just talking about that, I just said, look, yeah, I see at least 3 ways to do it, and there's this way, and there's another way, and here's the pros and cons. I think that this kind of usually impresses interviewers. Yeah, it was also at Wayfair. I also told the guy, I said, yeah, I have this solution will maximize time, but it will take more space. The other will take less space. And just talking about the trade-offs, and kind of also you can provide your arguments, why it is better. I think this is also pretty impressive. So I saw that they started to involve more actively with me, and yeah, this was what went well.
Okay. Yeah, so basically you were able to understand like the trade-offs between all your approaches for like data structures, algorithm, system design. And then because of that, the interviewer actually took you a little bit more seriously compared to like other candidates as well.
Yeah, they had this impression. Or even I remember again with Wayfair, there was some question. It was classic, maybe from LeetCode, something about some array question, and then I started like before solving it, or even before brute force, I started asking questions about the problem. Like, can values be negative in this array? It sounds so trivial, and I saw so many times, but he was also so impressed. He said that nobody ever asked those questions before. So this was also, and then later in feedback, I heard that it was also very. It came like they perceived me as a very detail-oriented. Although for me, I was just I used this time basically to think more about the problem, to calm me down, to get a bit more comfortable. And yeah, that case it was justified because if the values were negative, then it will change a bit the algorithm. But yeah, asking questions helps a lot. But yeah, of course, questions must be meaningful. It's also irritating when you ask some irrelevant questions, I think.
Yeah, no, we get those like clarifying questions. I don't know if you saw the last session before I had you on stream, but basically that's kind of like what happened there. Like people were asking clarifying questions, but they weren't necessarily meaningful. So yeah, like you being very detail oriented, you felt. Oh, we should mention that Wayfair was what you got the staff level job from. Did you? And you said basically that being very detail oriented really helped you there.
Right.
Okay. So, like, how'd you feel when you got that staff job, actually? Because I know we were aiming for, like, L5, but we got essentially staff for you. So, what was your feeling, like, when you saw the news and all that shit?
Well, yeah, I don't know. It was hard for me to calm down. I mean, I was just a lot of thoughts running in my head, and especially it just was like a call from first the headhunter, so to say. He told me, so it was not from Wayfair, but the person who introduced me there. And then, I was thinking basically how, like, what should I do? Should I accept this offer? Should like, what is my strategy? That kind of stuff. Yeah, but yeah, I felt ecstatic.
Yeah, you should be. Like, we got a result much higher than we anticipated.
Yeah.
Yeah. So, that being said, so I guess the juicy things that people really want to know are like the numbers. So, what were you making before, and then like what is Wayfair like paying you in your contract if you don't mind disclosing that?
No, I think it's fine. Yeah, so before I was getting, I'm talking about total compensation, right? Before I was getting 85,000 euros. So I think you can multiply by 1.17, you will get it in dollars. So from 85, and this was only salary. In most cases, there was no bonus, so it was pretty small, and no shares. And in Wayfair, so basically it's a bit more than 200,000 euros. So it's
yeah, that's still a freaking lot. Going from like 85k euros to 200k euros, I think anyone's gonna be happy with that.
Yeah, so it's more than 2 times, and it was pretty impressive, yeah, and it's pretty high. I don't know anyone with such high salary for software engineering. Because here in Europe it's also maybe not, like my impression, it's not so common like in the US. You have such high salaries and maybe you pay less taxes. I don't know really the situation, but in Europe I know it's a bit lower.
Yeah, no, it's we kind of end up with the same thing on like in Asia and everywhere else. Like only in like Silicon Valley and like New York do you get paid like those obscene salaries. But yeah, still like regardless, it's still a really good result. Although I was more sad that we didn't get the was it Uber and I think it was Facebook?
No,
or
Google.
Yeah, Google. Yeah. I think like at some point we recognized that the burnout situation was real.
Mm-hmm.
Yeah.
Yeah, that's real. And yeah, I can tell you about this burnout. Like when I had this Uber interview, yeah, I know it felt a bit like first of all, I didn't realize I had a burnout, so I thought I was fine. But then it's a bit like, as if you're sleepy or something, or half asleep. And yeah, as you said, it's autopilot mode. Yes, so basically, yeah, I apply my framework, but just for me, it was hard to go deep into questions. Yeah, I could only scratch the surface, maybe state the obvious and do some simple stuff, but then you don't see the big picture, and then you start making mistakes. Yeah, this is how I
Yeah,
experienced
it's
it.
like you just like stop caring and then you just like make little mistake after little mistake and it just kind of it just adds up in those interviews.
Yeah,
Yeah.
exactly. Yeah.
Yeah. But still, you did like really well. So I guess the people are frothing at the mouth of like, hey, what do you feel like made you the most successful? And are there any tips that you want to give to the people listening who might be looking at maybe not like an L6 offer, but like maybe just a normal senior offer or even L4?
Yeah, it's hard to say, but one thing I don't know. I think in this interview preparations, like what they also preaching, it's similar. I think this idea of deliberate practice is very important, and there is even a book which I also read and recommend. It's called Deliberate Practice, and there are many ideas that overlap with your ideas. And I remember also the book says also a lot. They basically this book is about people like professional world class violinist players, or chess players who are world class, yeah, and how can they achieve those results. And so the author emphasizes getting a good coach because, again, of the things you mentioned, because you don't know what you don't know. Yeah, and also some requirements about the coach. You should never be comfortable with the coach, that kind of stuff. And deliberate practice, also remember he said, it's never fun. So if you're doing something and you're enjoying it, it means it's not deliberate practice. So if you're enjoying it, it means you're not growing. So it's basically he says you should feel uncomfortable, because when those world-class players train, yeah, they're not comfortable. They all say they don't enjoy it.
Yeah. No, we don't enjoy like practice at all. We enjoy winning. That's it.
Yeah, because I came from that background when I was enjoying it. I like to, you brew your coffee, you maybe open your LeetCode, and you open YouTube, and then maybe you relax a bit, and then you browse to the solution of the LeetCode. It's super enjoyable. You think you learn something, but no, this is not how you. Maybe yeah, it just will take you much longer time, but you will not achieve results faster.
Right. So the biggest thing that you want people to know is like the better your practice is, the better your interview performance is. It has nothing to do with like, oh, you should do this little thing during the interview, like maybe you should talk more or anything tactical like that, because it's just a small amount.
Yeah.
What really matters is all the preparation before then.
Yeah, exactly.
Yeah. We have a question in the chat actually. So how do you have the energy to solve problems after a long day of work? Do you not get discouraged when it takes you a long time to solve the problem?
Yeah, that's a good question. I was struggling with this low energy stuff. I did have low energy also, yeah, because of my work and day work and meetings, and I had to also lead a small squad. My team, what helped me, well, yeah, of course, time blocking. So you set aside a certain time, which yeah, you also do this with your template. So yeah, you have time blocks, and you need to take them seriously. And what I notice what helps me is exercise basically. I finish my job usually at set time. Then it's very important. I just do exercises, aerobic exercises, that kind of stuff, because this resets somehow my brain. Yeah, exercise. Then you take a shower, then I come back, and then this is when I feel a bit reset, and then I can start doing something else. And also, as I said, I joined this group of people. Like there was a session for 3 hours or so, or 4 hours basically, and then you are together there, and you share with people what you're doing. Well, people are not really preparing for interviews there, but you're saying what you're doing, what you're working on. They also control the breaks, so they tell you when you need to take a break. So you also outsource this. Yeah, and with this time blocking and exercises, this is what helped me to reset my energy. And also, I basically told myself, I have those 4 hours, and I want to solve one problem. I don't care if it takes me 30 minutes or all 4 hours. I just want to solve this problem in a very with high quality and with the instructions that you gave me. Yeah, that's kind of my goal.
Yeah. Do you mind if I bring up your study sheet, like for the schedule?
Yeah, you can show it.
Yeah, I'm going to show it on stream actually. So yeah, I'm just showing them that you basically went to bed at like 10 p.m. 11 p.m. and then you woke up at like 6:30, right? And then you would and then you would wake up like from 6:30 to 7:30. You'd have like breakfast and do a 20-minute walk, and then from 7:30 to 9 a.m. you do some leak code. And then from 9:30 till like 6 p.m. you were at work, and then you had a 30-minute break after that, an hour break for dinner, do whatever you want, and then we blocked out from 7:30, like 7 o'clock to like 9 o'clock or 9:30. Like this would be like all leak code practice, and then we had a break, and then we had a little bit more leak code as well. So in effect, we basically made this like a part-time job for you on the weekdays.
Yeah.
And then on the weekends, we kept a pretty similar schedule on the weekends where, except for during the work hour, we added in like 2-hour blocks of leak code for your work, and then we had a break in between. And then since we had coaching on the weekend, we also put in like this extra 2 or 3 hour block of rest.
Right.
Yeah. So
Also, you mentioned also this in the morning. I had this walk. It helped me a lot. I don't know, maybe it's individual, but for me, I couldn't also work without this. So I really need in the morning, first thing after breakfast, I take a 20-30 minutes walk, and then you come back, you have some fresh air, and then your mind is already woken up. Because I also work from home office, and I don't need to go to work. And I think this is important to get also some small exercise in the morning.
Yeah. And I think if that works for you and it helps you like really, really focus, then I think it's actually completely great, because I do the exact same thing. Like after work, like I just go straight to the gym, and then after that I'm like ready to do things again. So I totally understand what you mean. Yeah. So I think that with that, I think that's all the questions that are from my side. It seems like you've pretty much like figured out what you want to do with regards to the offers. What do you think you would want to tell, I guess, anyone who is thinking about getting coached, or like, in general, what you think people should really know before they undertake something as brutal as this? Because, like you said, it's not fun. It's really, really brutal, because you're basically spending 4 hours a day studying on weekdays, and then on weekends you're spending another 9 hours. So it's like, what do you think the big takeaway is for people who want to really, really grind seriously?
Well, I think make it like a regular habit, and this is what helped me. So basically, I abstracted a bit from this notion of solving certain amount of problems per day, but it's more like do it in certain times and do it with high quality. Even like in this question, I see that what was asked in the channel, how do you not get discouraged when it's taking you a long time to solve the problem. It's also a bit similar here, in the sense, like if I have a problem which is too hard for me, like too complex, like what I try to do is, break it down into smaller steps, smaller pieces. I mean, for example, I see a big problem and I cannot solve it. It's hard with code. For me, the first case would be just solve it with a brute force, so to say. So this one is already would be a huge win if I just can solve it with brute force. Yeah.
Mm-hmm. So being able to take things like one step at a time really is like
right.
Mm-hmm.
Exactly. Yeah.
Yeah, that makes sense. And then someone says like their problem is that they study super hard one day and they stop the next day and then they feel super bad about it. But like you said, it's got to be a habit. It's like once you make it a habit, it just becomes so much easier to not really think about the stress and just like it's just something you got to do.
Mm-hmm. Yeah, and as I said before, I had also those days when you feel exhausted. But for example, I think you gave me this task like to study some AP chapters, elements of programming interview chapters, and like I roughly calculated how many questions I want to do per day, and then let's say I cannot it was like 2 or 3 questions per day I need to solve to meet the goal, and then one day I don't feel like solving anything, and I just thought, okay, I will give myself 3 hours. I have this blocked in my evening, and I said I don't care if I solve 3 problems or half of the problem, meaning just maybe brute force of the first one. You just don't need to be hard. I mean, this is how I was not hard on myself. But I said I will do what I can do in those 3 hours. I will do my best. But if it's little, I also don't mind as long as it's high quality practice. And then somehow my mind agrees with me, and I start doing small. And then somehow after, let's say 1 hour, I finish the first problem, and I said, well, actually, I don't feel now so bad. Maybe I can try another one. And this is how it goes. Yeah.
Right. Those 3 hours are dedicated to you practicing, so you're going to practice in some way and do whatever you can.
Yes. So I basically promised myself, if I want, I will just sit 3 hours straight and just stare at the problem description. But I have that time, and I can do whatever I want for this, for this practice, even if I don't achieve a lot of results. But just time block and give time to solve it.
Yeah, I think that makes a lot of sense actually. Because again, like the focus practice and all that. Because it's like you fall off the wagon, then it's like you feel bad and you don't want to do it anymore, and it's just like it snowballs out of control.
Yeah, and because before I had this, my thinking goes like this. So I think, okay, today is the evening. I don't feel good. I have a headache. Let's start this problem. I cannot solve it. Okay, then let's switch to YouTube. Let's switch to Facebook. Maybe let's play some games or something. Let's read some news. And you see, you already kind of immediately lose in this case. But if you have 3 hours and you're saying, okay, it's like if you cannot solve it, just sit there still for 3 hours and look at the problem. You don't have this option to switch, to context switch to other things. And this is what helped me.
Yeah, and I'm looking through like what's called the practice diary that you had. You spent like literally like an hour on like a single problem, just like whether it is solving it or just really trying to figure out what you did wrong with that. I kind of want to dive a little bit into that. What was your strategy for really, diffing between the optimal solution and your solution? How did you improve? Because, I have my way of doing things. I think you have a little bit different way of things. Like, how did you do it?
Well, I think it was what you also taught me, or some other people say. Basically, when I see my inefficient problem and then I see an optimal problem, of course I try to understand like how they come up with this stuff. And then for me, what it boils down to is basically you need to articulate, really need to see the efficiencies in your brute force solution, right? So if I see that I need now for each element in the array, I need another run, so a quadratic complexity. I want to understand like how can I prove that? How can I save that time? Yeah. So, or I don't know, I access some elements, or I recalculate some stuff too many times.
Mhm.
So just for me, it's just starting thinking in this way, like why is this brute force inefficient? And yes, sometimes it works, sometimes it not. But if I really see the problem and the issue, and then you talk about this, and sometimes even the interviewer will help you. He will say, yes, exactly, this is an inefficiency. How would you solve it? And then maybe he sometimes even throw some hint how you can do it better. Yeah. So for me, this is exactly the switch, from brute force, what is inefficient, and then really attack hard exactly that inefficiency. And this is how the optimal approach appears to me.
Yeah, so you just basically walked through a step-by-step progression, and then it's just like if you got stuck at a single step, then it would just be like that's probably something you needed to improve on.
Mm-hmm.
Yeah.
Yeah.
Yeah, so that makes sense. And so I know some people do it a little differently, but it seems like you followed something like pretty standard to like what I recommended as well. Yeah.
Yeah.
So I think with that, I think that's pretty much all the questions and comments from my side. Is there anything that you want to like tell the audience, like before we call it a stream? Anything you want to say, or if you want to do like a system design interview, mock?
No, maybe just one small thing also what maybe made me a bit more comfortable and more confident in interviews. Maybe I didn't tell you that yet. But basically, I have also, of course, a GitHub repository where I track my problems. But what also helped me a lot is just I started writing down typical brute forces for typical questions. Let's say if I see a graph in my brute force, I immediately write, you can traverse it using BFS or DFS. If I have an array, you can also then say just traverse array, just iterate over the array, and that's it. It just sounds trivial, but what it gave me is that when you first see the problem, and I know about other people, but me before I used to freak out totally. So your mind goes blank. But now when I see a problem, for me, I immediately see the brute force solution, and it's totally different game for me because I am already comfortable. I know that in the worst case, at least I will come up with a brute force. Maybe it will not be enough to pass, but still, at least I have already the solution. Yeah.
Yeah.
This was.
Yeah. So you have like a repository. Sorry, go ahead.
I just wanted to add that there eventually it was like, I don't know, not so many, maybe 12 to 15 typical brute forces. There are not so many, and I only realized that when I wrote them down. Yeah. And after you have this, then it's, as I said, you feel more relaxed, and then you know what's your brute force and how you optimize from there.
Yeah, so being able to like really record like your naive solutions, your strategies, your approaches, and then being able to like just record them and remember that those exist, and then you realize there's only a finite number, and then after that it's just kind of like the same thing over and over again.
Yeah, exactly.
Yeah, sounds good. I don't think there's any other questions in the chat, so I guess with that,
I see this. I see this question. Any specific way you reflected on problems? I think we didn't answer that yet, right?
I mean, yeah, feel free to answer it, dude. Yeah.
Yeah, this one it's not so easy. I tried to follow Edward's approach. What was it? Just to think about it and try to see inefficiencies and what would you do different next time. It's good. It helped me, I think. It's especially when you see similar problems, you already if you see palindrome problems, and you kind of already if you reflect before, you know what problems you might have. But also additionally, maybe you also mentioned this, it's also good exercise, at least for me, was to start building connections between the problems. I also have this practice diary, and sometimes I remember I like to find similarities between problems. When I solve a problem, I think, okay, this one looks pretty similar to that problem, and maybe you can also write. I wrote this down, maybe, and just then you realize there are a lot of similarities and connections between problem, and then you start to see the system. Yeah, this is how I reflected.
Yeah, so it's not just like seeing the mistakes and then trying to improve on them. It's like trying to see how you could apply them to other problems as well.
Yeah, exactly.
Yeah. Yeah, I don't have any other questions. Any shout outs you want to make? Any last final comments?
No, I think yeah, that's it. Yeah.
All right, for sure. Well, thanks for coming on stream, and I think some people might want you to do a system design interview mock later, but maybe that's for another day. But I know it's a little bit early for you, and thanks again for coming on stream and talking about this.
Yeah, thanks for having me.
Yeah, for sure, man. And once again, congratulations on your staff offer, man.
Yeah, thanks a lot.
All right, take care, man.
Bye.
All right, bye-bye. Right. So with that, I guess if there's any other final questions, feel free to ask them. Otherwise, I think I'm going to stop the stream for today. I think we've gone for like almost 3 hours now. I think that hopefully this has been really helpful to you guys. Thanks for watching. I'll try to answer as many questions as you guys got going. Otherwise, we'll call it a night. If you guys want to talk to Pavel, he is currently in the Discord chat. So feel free to ping him there if you have any questions about like what it's like to get coached or any specific strategies on being able to study, improve at problem solving, prepare for your interviews. He's there as well. But with that, I think yeah, that's gonna do it for me. So that I'll put on some Dota. Let's see now. Ooh, Chinese Dota. Nice. Alright. Well, if there's no more questions, I'm gonna stop the stream. So you know what? Good night, you guys. Thank you for watching, and hopefully we will get Darth Varg, the guy who was on stream before Pavel, to show us his replay. Hopefully make some improvement. Expect it to be on maybe Friday. Yeah, probably Friday, or Saturday for that stream, and then we'll see if he made any improvements. So hopefully you guys tune in for that one as well. If not, you can watch the replay on my YouTube channel. Remember, if you guys want to get coached yourself, you can book me for coaching at echantek.com. But with that, good night, you guys, and good luck on your interviews.